Okay, welcome to this new SimplyMaya tutorial on dynamics and fluids. In this tutorial we're going to be creating what you just saw in the introduction video, which was basically particles falling from the sky. When they hit the floor plane, they then give birth to a second set of particles. Both of these particle systems are emitted into Maya's auto-resize fluid containers. There's also a displacement ground plane with construction history on, which is a new feature in Maya 2011. This will allow us to not just fake blowing a hole in the geometry, but actually to blast a hole in the geometry. This will, if you watch closely on the introduction video, you'll see that when some of our bombs drop from the sky, they actually roll into the holes left by previous explosions. Well, I did it this way to show that we're actually not faking this, that we actually have achieved deformable terrain, if you like. Now, there are some complicated processes in this tutorial. I've done my best to simplify them, along with the scripting, which is done in the simplest way possible, so you can follow along. We're going to start out by creating the first particle system, which will be the initial bomb that drops out the back of our aircraft. Now, in this tutorial I've decided to use just a spaceship that I actually took out the resources section from SimplyMaya. I'll include all the models and all the scene files with this tutorial so you can follow along, but you could do anything from bombs dropping from a plane to missiles launching with this technique. Basically there's a wide range of usage. This is just to demonstrate the principle of tying multiple fluid emitters together with multiple nparticle emitters together with deformable surfaces. So not only do we get an explosion that goes up and out, we also get an explosion that would blow a hole in a floor, a wall, or whichever geometry you decide to use. Okay, in the interest of keeping this as simple as possible though, we'll start with just one nparticle emitter. So I'm going to create a ground plane first, and I'm just going to scale that up. Press 6 to go into a shaded view and turn off my grid. Now the first thing before I actually start, I want to just create a quick project. So new project, and I will call this bombing run tutorial, and I'll just use defaults and hit accept. This just creates a project for me, so it'll keep all my scenes, images, renders all in the same place. It's good practice. So first things first, then we need to be under the nDynamics tab. nParticle, create emitter, and I want to bring up its options box. Now before I do that, I just noticed that my nParticles were set on points. For this I want to use balls. So nParticle, create emitter, options box again, and I'm going to reset the options so mine's the same as yours, and this emitter I will call E for emitter, and then I'll just call it bomb. So create new solver, because we don't have one at the moment, and we're using nDynamics for this tutorial as well, which were introduced in Maya 2009. nDynamics is simply a updated dynamics engine for Maya, the N standing for nucleus, which is the solver that solves the dynamics for any version of Maya upwards of 2009. You can still access the old particle system, but it is quite depreciated now, so if you are going to do something with particles, unless you have a good reason for using the older system, I'd definitely recommend you take a look at nDynamics if you haven't done already. Now here we have the basic attributes of your emitter. So you can omni emitter, emit from all directions, directional emitter, a volume emitter. For this particular instance I'm just going to stick with the omni emitter. Now this is the number of particles the emitter will put out per second. It's quite self-explanatory. However, in this case we just want one with the speed of 1. We don't want anything fancy, we just want balls to drop to the floor, what eventually will be bombs. You have no volume emitter attributes available to you because we're not using a volume emitter, so I'm just going to go ahead and hit create. I'm going to then drop into the outliner. I'm going to make sure I've selected my EBOM 1, and I'm just going to hit W to move that up a bit from approximately where I want my bombs to drop. Okay, now if we just rewind, give it some frames to play with, and hit play, you'll see we get our, what will be eventually our bombs. And we will be later on in this tutorial also discussing instancing geometry to these, so rather than just a selection as you saw in the preview video, introduction video, rather than just a selection of round coloured balls, we'll actually have something that looks a bit more bomb-like. But for now, what we need is for these balls to strike this plane. So if we select the E-bomb, you'll see under here you have nucleus 1. This is the actual solver element that Maya will be using to solve these particles, so it contains things like the gravity and whatnot. Now, in previous versions of particles, you'd have had to have dropped in a gravity field if you wanted gravity. If you wanted wind, you'd have had to drop in a wind field. So I'll just cover some of the basic attributes here in the solver before we go any further. For instance, under previous particles, if you wanted a ground plane, you would have to put one in and then tell it to become a ground plane, a passive collider object. Here, with nDynamics, you can hit use plane, and you will now see that my objects just drop onto the floor. Now it's important to note they're not actually dropping onto this plane, they're actually dropping onto an invisible plane that you can set the coordinates of here. So for instance, if we put this, say, at -5 units in the Y, you'll see the invisible plane will have been moved much further down. So, and then you have things like bounce. So if I set the bounce up to, say, 10, you'll see that actually 10 is probably a bit extreme, because you'll see they've now bounced all the way up here. But I think you get the basic principle. It's quite simple. So there we go, bouncing balls. Actually, as we don't want bouncing balls, we won't set that. And the same goes to stickiness and plane friction. It's all quite self-explanatory. You can play around with it. The solver attributes, this is basically how accurate your solve will be. This is how many things Maya calculates every frame. So if you were to set this up to, say, 12, you'd get more accurate solve, i.e. more accurate collisions, more accurate, well, everything really. But as you can see, this does slow us down a bit. So for our intents and purposes, I'll leave it at the default 3 for now. So nDynamics has some of this built in. For instance, a wind speed of, say, 25 in the X direction, and you'll see our particles now act like there's wind on them. So if you've never used nDynamics before, but you have used Maya Dynamics, you'll understand that this is a little bit easier to use. They've built in some of the basics, whereas before you would have had to use dynamic fields to control these basic elements. Hey, but for our intents and purposes, all we want is one emitter that's going to drop the first bomb. So I'll just actually move this back to its default location. Now for these bombs, it's nice that we have the option to use the nucleus solver to create a plane for us. The problem with that is that we actually want to blast a hole in this, and when the next bomb drops, it needs to drop into that hole, and with a ground plane I can't do that. I need actual geometry. So for now, I'm going to turn this off. I'm going to select this. I'm going to go up to nMesh, create passive collider, options box. Now this will let us make a passive collider for the nucleus 1 solver. If we had multiple solvers in our scene, then it would give you the option. You also have the option to create a new solver. But for right now, as these particles are controlled by the nucleus 1 solver, we obviously want to tell them to hit the ground. So the ground also has to be controlled by the nucleus 1 solver. So I'll just make collide, and you'll see here that they drop on the floor. Now they do have a little bounce on them. This is because our particles themselves, if we go under the nParticle shape and we go up to, let's just get rid of all this and go to collisions. You should see here that they have a bounce of 9. We don't want it. We don't want bouncing bombs. So now they should just strike the floor and stay where they are. Now these will eventually also be tied to another emitter, which is a fluid emitter, which will allow us to create the explosion when we hit the floor. But first, what I'd like is, when my explosion goes off, I'd like it to be sort of a mini nuclear blast, which will go up and out at the top, but also we need to blast fluids along the bottom of the container, shrapnel if you like. So how we're going to achieve that is we're going to have these particles emit a secondary particle system. So maybe it's a bit easier if I just do this for you, and then you can see what I'm talking about. So I'm going to select this nParticle, which if I just press play you can see selects the actual particles, because it's these particles I want to use to emit other particles. So select this, go up to nParticles, create nParticles, and on this one I want to use points. So nParticles emit from object. I'll just select and reset settings. So I'm going to actually call this E for emitter again, and I'm going to call this secondary. And a directional emitter is what I want, because I want the blast to go outwards. So in our case this is not relevant because we're going to use per particle attributes. So we need to be able to tell each of these particles to set this rate of speed. But for now I'll just set this to 6 so it doesn't go crazy. And we'll probably want a speed of around, I don't know, I'll go for 8. We'll tweak these values when we get a bit further down the line. And again, all your volume attribute options are grayed out because we're using a directional emitter, not a volume emitter. So if I just hit create now, you will see if we look under nParticle shape 1, there's a secondary emitter attached to it. So a primary emitter, secondary emitter. So if I hit rewind and play now, you will see that these particles are giving birth to these white point particles. The problem is that they're actually colliding with the particles, and this then pushes them away, as you can see. So this is not at all what we're looking for. We need the bombs to fall straight down and then the collision to happen. So there's a couple of ways we can solve this problem. The easiest way is, because all of this is under the nucleus 1 solver, it's all going to interact. So probably better thing to do is if we just delete this and this. So basically we delete what we just created. I just wanted to show you this so you could see the interaction. And then we select the nParticle 1 again, and we go up to the same, and we emit from object exactly the same, and you'll have the same values from the last time, but rather than using the nucleus 1 solver, we'll create a new solver. So now I hit create, and you'll see that now I have my particles being emitted like so. But this is not very explosion-like, so we'll take some strides to collect that. And again, it will still be under nParticle 1, secondary emitter for the secondary explosion blast. If we go here, we want its basic emitter attributes, and we don't want this to output in a direction of X, we want it to output in a direction of Y. But now you can see they're going straight up. Now this is still not very secondary blast like, so in order to take care of that, you can change the spread here. You can think of this, if I put this to 0.5, it might help you visualize it. You can think of this as 0 being straight up, as so, and obviously they're being affected by gravity because our nucleus solvers by default have gravity turned on. If I just turn gravity off on our second nucleus solver here, you can visualize this more easily. Okay, so a value in the spread attribute, which I'll just go back to now, of 0 is going to emit these in this direction straight up in the air. A value of 1 will emit them around a 180-degree arc at random. So much more explosion-like. But what I'm going to do is I'm going to set mine at 0.95, and I'm just going to turn the gravity back on the nucleus solver. 9.8. Okay, now we have a look. You'll see that we get our particle emission, okay? So we now have particles giving birth to particles. The problem that we have now is we want the bomb to explode when it hits the floor, not when it's dropping out of the sky. And to solve this problem, we're going to have to do a little bit of scripting. We also need these particles to die, and we need, of course, these particles to die at some point. So in the next part, we're going to come back and we're going to solve both of those problems. We're going to dive into a little bit of MEL scripting for controlling emission rates per particle, and we're going to make this look a bit more like we want it. We're going to use an acceleration ramp to control the secondary emitted particles also. So I hope this has been understandable and easy enough for you, and I'll see you in the next part. Okay, welcome back. Here's where we left off. So we have our primary particles, which will be our bomb, and then we have our secondary particles, which will be our shrapnel. Now, as mentioned in the last part, the problem is that the shrapnel starts emitting as soon as it leaves the emitter. So there's one simple way to deal with this with MEL script. What we need to do is we need to use a per particle rate on this. So the first thing is click it, go up to nparticles, and per point emission rates. So if I click this here, and then go to my eBomb nparticle 1 shape, if I go down to per particle array attributes, you'll see E secondary, which is our shrapnel, rate per particle. So I need to go in, oops, pardon me, just close that. I need to go in here and runtime before dynamic expression. Okay, now if before I do that, sorry, I just play, and you can see now we've set this to use per point emission rates, excuse me. It doesn't emit anything at all. This is because it's now controlled from this. So like I say, runtime for dynamic expression, and if we just copy this, paste it, Control C and Control V, which you probably already know, and we say equals 6, and we hit create, this will now give us the same result we had before we used it. What we want, however, is for these to emit as soon as these hit the floor, or maybe a little bit after they hit the floor, because we're not going to do this explosion on contact with the ground plane, because as I say, we're going to be deforming the terrain, and we want people to see that it's actually been deformed and it's not just some cheat with a bump map. So we'll want the bomb objects to roll a little bit before they explode. So we need this to emit these particles when it hits the ground. So I'm just going to type if, and what we need to say is nparticle 1 shape age. So I'm going to do a bit of copy and pasting again. Age is greater than, let's try 1.5. Then do this. So if the age of our primary particles is bigger than 1.5, it will then emit these particles. And I'll just put else, and I'll just copy and paste again. Rate equals 0. Okay, click edit, and you'll see down here, if this goes red, you've made an error in your syntax somewhere in your script. And now when I push play, you can see that they start emitting when they hit the floor. But it's not a very good emission. It doesn't really look like a shrapnel blast, and it goes on and on and on and on and on. So what we need to do is we go here, we'll set this to say 600. So we know that when this hits the floor, there we go, this looks more like shrapnel, but again you've still got that problem that it continues to live. So I actually want to give these a bit of a longer lifespan, so I'll delay the explosion. They'll hit the floor and sit there for a while and then explode. Okay, so if I look at my expression, 1.7 is the age that I've decided that these should start emitting particles, so that gives them a chance to hit the floor and roll a little bit. So if I go up to here, make sure I'm under the nparticle 1 shape node and go up to lifespan, if I put this to constant and then 1.8, you'll see what happens now. Now we're starting to look a little bit more like an explosion. Okay, but I think I'll actually set this to 1.9, and that gives us a little bit longer to live. It also gives us a little bit more particles emitted before the primary particle dies off. Okay, so now we're looking like mini explosions with just a small tiny bit of scripting. The other thing is, because our points here use the nucleus 2 solver and not the nucleus 1 solver, and this n-rigid plane here is set to act as a collision object for nucleus 1, so it has no effect on particles that use the nucleus 2 solver. We'll need to sort that out. And because this is just going to be shrapnel, i.e. more like a big puff of smoke along the ground, I'm just going to select the secondary here, go to the nucleus 2 solver and click use plane. Then we probably have a little bit too much speed on these because we want to design small explosions, not great big huge monstrous ones. I'm just actually going to set my playback speed to real time. You can only really do this, you probably shouldn't do this unless your machine is capable of simulating much faster than what your real time is set to. So this should work for now, but later on you're not going to be able to do it. So you can see here that my nucleus solver is complaining that we're going too fast. But this will just give us a little look at the timing, which seems about right to me. We can tweak it later when we start to play with the fluids, of course. So now you have this event, primary particles giving birth to secondary particles after they've hit the floor. And as I say, we don't want it to be a contact event. We want to give the bomb a little bit of time to sit there. But now our secondary explosion is a bit too big, so I'm going to go to its speed attribute for a start, and I'm going to click its speed and see what we get with a speed of 5. Okay, that's a little more like I was after. The problem is everything moves at the same speed. Now I envision the particles that go outwards this way and this way along X and Z should be moving faster than the ones that go straight up in the air. So in order to solve this problem, we can use an acceleration ramp. So if you want to go up to your nparticle 2 shape and go to per particle attributes, you can use ramp acceleration, create ramp, particles age is fine. Okay, and then if we go to edit ramp, we don't actually want the ramp colors. What's going to happen here is if we select the color and make sure we're on RGB 0 to 10, Maya will actually use this as X, Y and Z. So for instance, if I set this to 0, everything set to 0 will have no effect. If I set green, which will now act as Y, to 10, you'll see we kind of override gravity in that direction. So I'll demonstrate, as you can see. So by tweaking this, if I set this to maybe 3, I should get the center to go up a bit more and a bit slower because it's going now straight up and straight down. So I get the pattern I'm looking for, which is this kind of circular radial explosion pattern, with the outside appearing to move faster than this middle portion. Okay, so that's basic ramp acceleration, and this leaves us now with just, it's going to be easier for us to see how our bombing run is going to look if they're not all falling in the same place. So just to quickly come up with something, I'm just going to use the EP curve tool, and I'll actually go into the top view for this to draw a quick curve on here. So it doesn't have to be too precise, I just want to get a basic movement. Okay, I'll press return to finish the tool, and then I'll go up to surfaces, edit curves, rebuild curve. There we go. And this I'm going to use as a motion path for eventually our spaceship to follow along with. But for right now I'm just going to tie the emitter to it. So I'm going to go back here to my perspective view. I'm going to bring up the outliner, make sure I've selected the curve. I'm going to drag that up. Oops. I'm going to drag that up to just about under the emitter here. I'm going to select the curve. I'm going to select the emitter. Oops. Control select, not shift select in the outliner. And under animations, so I go to animation menu, animate, motion paths, attach to motion path. Now that should be fine on its default. And this now gives us a better look at exactly how we're going to be dropping bombs on the floor. It lets us adjust the timing a bit. For instance, I think this secondary explosion is still a little large. We'll tweak this again when we put fluids on it, but for right now I'm just going to go back to E secondary under its basic emitting speed attribute. So I'm going to change this to say 3, and I'll give that a go. Okay, I think that's a little better. We'll have to tweak it when we start playing with the fluids. But with just a little bit of scripting, what we've done is we've got these secondary emitters to be born exactly when we wanted them to. We've controlled the emission rate of the secondary emitter, so we can make our secondary explosion larger or smaller. We can emit more or less particles. That's just a very simple piece of mail scripting. What we're going to do in the next part is we're going to look at adding the first fluid container, which will be used to actually create the deformations in the floor. We're also going to be looking at adding a point light that will actually follow these particles around and blink when the explosion is supposed to happen. So this will give us that flash of initial light for the explosion. Okay, I hope you found this part interesting, and I'll see you in the next part. Before I go though, I will just put my playback speed to play every frame free, which is what you should have it on when you're working with Dynamics. Okay, see you in the next part. Hi, welcome back to the third part of our Maya Dynamics tutorial. We left off here, a couple of different particle systems and a little bit of mail scripting that we delved into to get the timing right. In this particular lesson I want to have a look at creating actual explosion damage to the floor plane, by which I mean I want to change the texture of it when the blast goes off. I also want to have live displacement, and I want that displacement capable of affecting other particles that might fall into it, i.e. if we blast a hole in the floor, the next bomb that would drop down would actually be capable of dropping into said hole. So not just at displacement at render time, but actually live displacement. We're going to use Maya's new displacement with construction history to achieve this, or new for version 2011 I should say. So as you probably remember if you're following along with this, there's what we were left with. Now a couple of things occur. This ground plane's probably a bit too small, especially when our explosions start to get a bit bigger. So I'm just going to hit R and scale that up a tad, just to give us some space to work with. And the first thing we're going to want to do is, when one of these things hits the floor, we want it to create a hole. Now we're going to do that with displacement, and eventually displacement with construction history, but for right now I'm going to fake it with a bump map so we can get the effect we're looking for, because as soon as you start playing around with displacement, it's going to slow everything down. So it's better for us to do these first initial tests with just a bump map to make sure the effect that we're looking for is working. Now the way we're going to get the bump map and the displacement and eventually the transparency, and we'll use transparency to mix two materials together via a Maya layered material. If you've never worked with a layered material, it's just allows you to mix several different materials together in Maya, several different shaders together. We'll cover it in this particular lesson. So the way we're going to get those bump, transparency and displacement maps is by using a 3D fluid texture. So let's go ahead and create one of those. I'll just assign a material to our ground plane, so assign new material. I'll actually just assign a Lambert and I'll call this ground. Nice and simple. And then I'll go ahead and open the hypershade. Give that 2 ticks. There we go. Right, so I have my ground here, and what I want to do is use a 3D shader. So I'll go up to 3D textures, and I'm going to use a fluid texture 3D node. So I'll clip this here. Now, as you can see, as soon as I create that, it's given birth to a 3D fluid container. And if we take a look at its attributes under the outliner, if you've used 3D fluid containers before, this one's pretty much exactly the same. And we're going to use it as a texture, however. So what we're going to do is we're going to, let's see, make this 15. We're just going to resize it so it kind of fits our plane here. And 0.1. Now this is the side I'm actually going to have lying flat. So if I just make this 90, you'll see why I've made one so thin. And the point with 3D fluid containers is the larger they are and the more resolution they have, the longer they're going to take to calculate. Now for us specifically, we don't really need a high level of resolution in this, because we're just going to use it, as I say, as a transparency, a bump and a displacement map. So what I'm going to do is keep voxels square, and then I'll go for a resolution of say 35 to start with. So what we'll do is, if we play now, you'll see nothing will happen. Because even though this is a 3D fluid, it still needs, and it's just a 3D texture, sorry, it still needs an emitter to emit into it. So I'm also going to scale this up a little bit. Now normally I would never do this. I would change a fluid container's size here by just scaling it here. What you're going to find is it could have a weird effect on your fluids. You'll get low resolution, pixelation and whatnot. But as I'm only using this for, as I say, the maps, then it really doesn't matter. I can scale it here, and we'll look later on between controlling this size and the actual scale we use for it. We can then vary the size of the blast hole that this will create in the floor. We'll go into that in a bit more detail a bit later. So what we have now is not a lot going on, as I say, because we need an emitter to emit into this, and the perfect thing would be if we could use our primary emitter here that drops our bomb to emit onto this when it touches the floor. So what I'll do is I'll select my 3D fluid container, and if you're having problems following along at the moment, just bear with me for 2 minutes and it should become very clear to you how this is going to interact with the ground plane. So I'll just select this and I'll select my nparticle 1 shape, and then I'll make sure I'm on Dynamics, add edit contents, emit from object. Actually bring up its option box and just reset it. So here I'm only actually going to be emitting density, so I'll turn off both heat and fuel. I'll leave this on 1 and I'll leave everything else on default, and I will just call this emitter fluid hole. So now what happens, you should be able to see this, is if you can see these striations on the ground here, this is actually fluid that's been emitted into this container. The problem is, if you'll notice, it's actually moving. And as we're going to use this as a displacement map, what would happen is we'd use this to map the hole, and then as the animation went on, the hole would actually move across the ground, which is most definitely not the effect we're looking for. So what I'll do is I will go to the 3D fluid texture container properties, and I'm going to turn everything off, off, and I'm going to set this to static grid. This way it will just drop on the floor, and you'll see now it's not moving, but we do have this textured pattern appear on the floor when our bomb drops on it. Now, in order to illustrate this a bit better, I'm going to actually tell this now to be a bump map, so we can get a better look at exactly what's going on. Because if I render this now, you'll see that nothing has really changed. You can't really see the fluid that's been emitted, nor can you see what difference it's made to our scene. So I'll bring up my hypershade, and here is my ground material. I'll just click on that, and where the bump mapping is, I'll just middle mouse drag that and drop this on. I'll change the bump value to, let's say, 4, so we can see what's going on. And now if I render, you can see we've created little bumps wherever a blast particle has hit. So I'll just take another snapshot of that so you can see that it matches up with this here on the ground. Now, this is quicker than displacement. It also allows us to do some error correction. We can see that it actually works, whereas if we'd put the displacement on it, it would have taken a lot longer. So the second thing we need to do here is, this is not very exciting. Apart from creating a bump or a big displaced hole, I'd also expect this ground around the blast to go blackish, brownish, like a bomb had gone off on it. So in order to achieve that, we're going to use a Maya layered shader. And if you've never used a layered shader before, it just allows you to take 2 other shaders here and mix them together, or 3 other, 4 other, or however many you want, really. So we'll go up to favorites and create a layered shader. Now, I'm just going to use my ground object as part of my layered shader. I'm also going to create another Lambert here, and I'm going to call this ground blast. So the ground will be the colour we always want the ground to be. So this could be a textured grass colour, tarmac, whatever it is you're blowing a hole in, and the ground blast will be the colour it goes after the hole has been blown in it. In fact, it's probably easier to show you. So I'll put this down here. I'll just middle mouse drag the ground down here, and now you can see we have the bump map that was originally on our ground. And we also have our ground blast here. So I'm just going to click my layered shader, drag across my ground blast, middle mouse drag across the ground. Going to just kill the one it already had in there. So now you can see that my layered shader is connected to both my ground and my ground blast. I also want to connect my ground blast to this bump, because after the ground has been blasted out, I still want it to be bumpy. So I'll click the ground blast, middle mouse drag this bump map, and now we've made the connection between these. Let me just organize this. And there you go. So we have one layered shader, ground, ground blast, bump map, and the fluid texture that's creating the bump map. Now the problem is, if I make this ground blast a horrible green color, and then assign my layered shader by middle mouse dragging it to the ground plane, you'll see here that it's just pure green. Now what this layered shader is doing is mixing these together. So if I turn the transparency of my green down, you'll see that I get the difference between the green and grey of the standard grey Lambert. So what we need to do is turn the transparency up and use this fluid texture as a transparency map. So again, middle mouse drag onto transparency, and this time when I play through, you should see green holes or green circles start to appear when I drop my bombs here. And we've got a bit of texture repeating here, that's fine. You can just make this slightly larger. And there we go. So there's our proof of concept basically. If I just take a quick render, you can see that we're creating holes and they are bumpy, although it's difficult to see with no lights in the scene. In a second we'll fix that. So now we know I use this horrible green color because it's very, very easy to see that it's actually working. Now I'm going to change it. So I'm just going to click its color and I'm going to use a fractal, and I'll leave this at default settings here. You can play around with it to get the effect you want. I'm just going to turn the color gain to a brownish, darkish brownish color. Okay. Now if I just resimulate again, and render, you can see I have much more what looks like could be holes in the ground. Okay, so one thing is that they're not really large enough. The other thing is they don't look so good at the moment. So what we're going to do to try and compensate for this, before we put in the live displacement, is we're going to drop this bump depth down to 2, and then we're going to select our fluid container. We'll scroll down to its texture attributes. We want to texture the opacity, and there's different texture types. Again, have a play around with it. In this instance I'm going to use wispy. I'm going to use a max depth of around 6 or 7. Let's go for 7. And I'm going to use a texture frequency of 6. I'm going to up this frequency as well in a second, just to show you what difference it would have. Okay, let's just do a bit of a zoom in here. And there's our previous. And here is our next. So you can see the bump starting to take effect now. It's still not very hole-like, and also I'd like this to have a bigger impact. So what I'm going to do is I'm going to up the amount of fluid released, possibly the fluid density. So if we just take a look here in the container, scroll up, and we will see a base resolution of 50. You'll have to resimulate when we change the resolution. Okay, that really hasn't made a huge difference. It's a little more defined, but it didn't really slow us down a lot, so I may just keep it at 50 for now. As to making these larger, I'm just going to scroll this up, resize that up, and when I hit go now, you'll see that it creates a larger hole around itself. We'll have to tweak this when we get to the proper texturing and lighting stage when we design the explosions, but as you can see I've got a much bigger impression when I hit the floor. Problem is that without the displacement it just looks like a bumpy rough patch on the ground, so we're going to go ahead and add some displacement now. So if we bring up our hypershade, now I'm kind of happy with the way it looks. I can add the displacement. So actually I'll just click on this layered shader and hit graph network. Now I'll click here, and what we want to do is bring up the shading network for this, the shading group for this. So if we click here, input and output connections, you'll see the layered shading group. If you click here, you can access the layered shader 1 shading group up here, and up here you'll have a place for a displacement material. The thing is, you have to add displacement to a layered to a shader shading group. You can't add it directly to the shader, which is why we have to bring up the shading group. So I'm going to again use this fluid 3D texture we have as a displacement map, and I'm just going to throw it on there. And now you should be able to see when we render, we actually get some displacement. You won't see it here in the viewport yet. So now when I render, it's a much more pronounced effect. Actually zoom in. And do this again. You can actually see that we have some cracking, we have some more displacement. It looks slightly larger than a bump map would. You'll probably notice as well that it's actually the wrong way round. It's pointing upwards when we're not trying to blast a mountain range, we're trying to blast some holes in the floor. So we'll take care of that in a second. The other thing is, this reaction happens, this blasting a hole in the floor, as soon as this bomb hits the floor. It's happened already, but it hasn't exploded yet. This is obviously no good for our purposes. We want this hole blasted in the floor when this explosion actually goes off, not before it goes off. So what we're going to do is we're going to go to our hole fluid emitter. So this is emitting the displacement maps and whatnot for the hole we're going to create, and we need to assign nDynamics menu, and we need to assign per point emission rates to this, so we can script it like we scripted this E secondary blast here, this one here. So I'll just click per point emission rate, and this way when I go up to my nParticle, look in per particle array attributes, you'll see I now have one for our emitter fluid hole. So what I can do here is runtime before dynamic expression, and I'll just copy it from up here. It's quite simple. So basically it just is the nParticle shape 1 node EF hole emitter, the rate of that emitter. Let's say if we make that 100 to try that out, and then once we've turned it on, we need to turn it off. So we'll just set that to 0 and hit edit. You'll see here that it's been edited. So now when we drop, you'll see no hole has appeared. Now you see a hole appear, and with us emitting that many particles, it should be quite a whopper of a hole. Let's do a quick render. Find out. Yep, see, this is a bit too much. We've now created a mountain region, and even if we inverted that, we don't really want this flat bottomed, we want more of a gentle sloping curve. So what I'll do is I'll take a look at this expression again. So runtime before dynamic, and we'll make this, we'll try, let's say 15. Edit. You can tweak this obviously for the effect that you're personally looking for. Okay, that's okay. Now we'll render this, and we get a bit better sort of cragginess, it's not a flat plateau look. The point is as well, now we're rendering displacements. I prefer this to do this with mental ray, so I don't have to add massive amount of geometry to this to get the displacements to render nicely. So what I'm going to do is select the ground plane, go up to create, and to render displacements in mental ray properly, I'm going to create a displacement approximation editor, which is just a fancy way of saying I'm going to do this basically. Rendering mental ray approximation editor, displacement for this plane, create, and what this will do is give me a mental ray displacement approximation. So if I go up to my render window here and select render with mental ray, you'll see that I get a much better displacement without the cracking and jaggedy edges. If I turn this up to high quality, you'll see I get an even better displacement. The problem is that takes a lot more time. So there's, you know, horses for courses. This is quite fast at the moment, but again, it's down to your machine. I mean, I can set these subdivisions, say up to 8 and 8, which would be very high, and render. And now it's going to start to take some time. So it's a cross between quality and, you know, what you can get away with. In this final animation, our camera is actually going to be moving, so you know, you're not going to need your displacement to be spot on perfect. The eye's not really going to see it that well, and also this is going to be a hole, not a mountain range, so that's going to let us get away with a lot more as well. So for now, as you can see, once you start playing with displacements, especially with a higher quality, you can start to really jack up your render time. So for now, I'm just going to put this on grid medium quality, and we'll see how long that takes to render. Should be 2 seconds. Yep, that's fine. Now, our big problem at the moment is that these displacements are going up, not down, and that's an easy one to fix. We select our fluid texture, scroll down, and under its color balance, change the alpha gain from 1 to, say, -1, and now when we render, you'll see we have holes. So if I actually just let that run out a full sequence, you'll notice another problem as well, that this bomb here would have fallen on the edge of this hole and then rolled down into the geometry. Unfortunately, we're not actually creating geometry, we're just creating displacements at render time. And this is not what we want. We want these to actually fall in the hole. We can do this quite simply in Maya now from version 2011 by just using displacements with construction history. The problem is, as soon as we start to do this, we need quite a lot of geometry on this mesh, and so it will slow down the entire simulation process. So for now, we'll just leave this shaded portion here. You can see we've started to blast holes. We'll need to tweak this a bit, but you know, if we just let this play out a full sequence. But you know, be aware that towards the end of the tutorial, we're going to actually come back and make this geometry live, and these deformations will actually affect where the next position of the bomb lies. Which is pretty cool. The reason we're not doing it now, I say, is it will slow down every simulation we do, and when we start to texture the fluids for the explosion, we don't want to be doing the live displacement plus the fluid texturing. But there you go, there is your holes in the floor from your explosion blasts. What I'll do in the next part is we'll look at starting to texture the fluid. We'll also look at having a point light turn on over the explosion when it goes off, so we get that initial bright flash of light. I was going to do that in this part, but I think this is enough for one lesson. And I think we have now what look like pretty good holes in the floor. So I'm going to be back in a while, and I hope to see you for the next part. Thanks for watching. Okay, welcome back to part 4. In this part we're going to start by just taking a look where we left off in the last part. And as you can see, we have our primary bomb fall to the floor, create these particles, and also do this displacement that we took a look at last time. So we know we have these holes being blown in the floor. And if you'll remember, we are going to eventually get those to do an actual live geometry displacement. But for right now, we were keeping it like this to aid our simulation time. Now, one thing is our simulation here is a bit slow maybe, because my fluid container is still set on a resolution of 50. My 3D fluid texture, should I say, is still set on this resolution of 50. So I'm going to knock that down to 10 for now. And if you'll see if I can play it in the right direction, what you'll see is this happens a bit faster. Now for the final thing, I'll probably use a value of around 50. But for this, because to keep the simulation time a bit better, what we're going to do is just bump that base resolution down a bit. So what I'd like to achieve next is get a point light to appear where these initially hit the ground. So to create this sort of bright flash of light that you can see when a bomb goes off, I'm going to do this with a point light. So what we need to do is we'll need a point light in the scene, but we'll also need to create some Mel script capable of turning on and off a point light at the right moment. It'll also have to be able to move the point light to the correct place in time. So I'm just going to go up and create a point light first of all. Okay, I'll just move this up a bit. And this is the light obviously that we're going to use, the one that's going to create that bright flash. So as I said, it needs to know not only when to turn on and off, but it also needs to know where to be located. So each particle it interacts with. So every time a particle lands on the floor, this light has to move there and flash. So I've just turned its intensity down to 0. So I'm just going to go up now under its rate pp, and I'm going to have a look at the scripts that we'd previously written to turn our emitters on and off. And what I'd like to do is get more control over this. So rather than just saying if the nparticle shape age is greater than 1.7, I'd actually like to gain more control over that by saying if the age is greater than 1.7 and less than a certain number. Now this will depend on how long we want our emitters to emit. In this case I'm just going to say and is less than 1.8. So if it's greater than 1.7 and less than 1.8, our emission here will happen. What I want to do now is select the point light. So I'm just going to type in select point light 1, and that has to be the name of your point light, of course. And I'm also going to want to change the point light's intensity, because by default it's turned off. So I'm going to have to do this by typing the point light shape 1 dot intensity, and here of course it helps if you remember how to spell, and I'm just going to turn that intensity to 5. Now what this will do is select the point light and then flick it on. So let's just hit our edit button and see where we go with that. Okay, I'll just make sure I'm using all the lights so we can actually see what it does in the viewport. Okay, it drops in, it comes off, but it goes on, as you can see, but it doesn't turn off. So let's have another look at that. Just going to select my expression here, which you can do by going to select filter and then flicking that to expression name and then selecting your nparticle 1 shape. So let's see what we have here. Okay, so you can see there where it turns on. Now we're just going to say else if, so if it's older than 1.7 but younger than 1.8, or down here if it's older than say 1.9, we want to turn the light off. And there's many ways of doing this. I'm doing it this way because it gives me a better degree of control. But this is one way of doing it. There's a few others. So now we're just going to set that point light shape 1 intensity to 0 and hit edit, and now it should turn off and turn back on again. So let's just have a look at that. Okay, it's on at the moment and it's not turning off, so we'll just make sure that that's not a simulation error. It's not, so we obviously have here some sort of simple typo, so I'm going to go back in. I'm just going to read through this just to make sure there's nothing glaringly obvious, and what I'm going to do is I'm going to set this one to a constant, so if this is equal to 1.9, okay, so obviously that is not our problem here, and it shouldn't have been either. There's obviously a very simple typo in here, so I'll just set that back to greater than 1.9, and if you'll just bear with me a second, it's just there's something in here that's quite simple, some sort of spelling mistake, or oh, there it is, I see it. If the particle shape is greater than 1.7 and greater than 1.8, it should of course be less than 1.8. So now we should have that working just fine. So light comes on, turns off, comes on, turns off, comes on, turns off. Okay, that's exactly what we want to happen. We want that point light there to flash the moment our bomb hits the floor. We want it to flash on with an intensity of 5, and I'm just going to change the colour as well. Give it a more blast-like orangey colour. Obviously this is completely dependent on what sort of explosion you're going for, but just for now I'm just going to tweak this so it's a bit more blast-like. So there you go, we've got this point light that now flicks on and flicks off at the exact moment that our bomb hits the floor and explodes. What we want to do is take our point light now and have it actually move to the place where our bomb explodes. So rather than staying in the center of the screen, we want it to actually move to where the particle first hits the floor, flash on and off, and then jump to where the next particle hits the floor and flash on and off, instead of this just going off in the middle of the scene here. So I'm going to go back to the expression editor, which you can also get to under the animation editors. You can just click it there if you don't have yours still open. Okay, and the first thing I'm going to need to do is you can also of course select by filter and make sure you're on the right expression name. The first thing I want to do is actually get the positional information for our nParticle, and this I can do by declaring a vector and then a variable. So I'm going to declare a vector variable called position, I should think, and then I'm going to have that equal the particle shape 1, and instead of its age like we've used before, I'm going to have that equal its position. So now what I've done is I've stored the x, y and z position of the nParticle 1 shape in a variable called POS, and if you just hit edit there you'll see that that's successfully been accepted. Now I'm going to need to assign a floating point variable for each of the x, y and z positions, so I can then later use that to move this light. So if I just use a variable I'll create here called position y equals POS, which is the variable we created earlier. So now I have a floating point variable which contains the y position of our nParticle. So I think you see where I'm going to go with this. I'm just going to create one for x and z as well. So there you go, zx. It doesn't matter which order you do this in, as long as you know what you're naming your variables, so you know where to find them. So I just call mine position y, position z and position x, because it makes it nice and simple. Now if we go down to where we have our point light shape 1 selected already in order to change the intensity, now we need to move it, which we can do simply by typing xform minus t and then giving it our x, y and z positions that we've stored in our floating point variables, position y, position z and position x. So I'm just going to go and copy and paste, and I'm just going to paste this in 3 times and then change it to position x, position y and position z as you'd expect. And then I'm going to go ahead and edit to see I have an error because I've forgotten to put semicolon at the end of the line. And you must remember that when you're doing this mail scripting, in order to bring the line to an end you need a semicolon. Okay, so this should actually now move our point light to where our explosion would happen in space. Okay, light flicks on and off, and as you can see, the point light is actually moving to where the particle falls on the floor. So that's just a quick brief look at some of the things you can do with this Mel script. For our final effect, I quite like this moving light as well, but I actually put it in here just to show you some of the ways you can use Mel script. What I'm going to do also, before I forget, is I'm just going to put a straight directional light in the scene, so we're not entirely dependent on this one point light, and I'll just crank its intensity down and sort of move it out of shot as well. Okay, this just gives us an overall level of illumination to start working with. Okay, now we have our overall level of illumination, and we also have our bomb going off here. It's about time that we started to look at adding some fluid containers to this scene, not for texture or for displacement, but for the actual bomb blast itself. So we're going to go ahead and we're going to create a 3D fluid container. And we're going to set that up a little bit in this part. So first I just want to go up to the Dynamics menu, and Fluid Effects, Create 3D Container. I'm going to bring up its options box. I'm going to reset that to basics so you'll have the same as me, and you'll see here I now have this fluid container in the middle of the scene. So this is what our bomb particle is actually going to drop into. You can see that at the moment by the squares on the bottom we have a relatively low resolution. So if I make this larger, so it would contain our entire, sorry, I'll just drop that one down to 10, I think, like that. If I make this larger, so it will contain our entire line here, my resolution is not so good. I've got a base resolution of only 10, but it does contain our entire line. The big problem with this is that this, as it keeps dropping bombs along this motion path, this is going to need a lot of resolution, and this is going to be quite slow. So with the new feature of Maya 2011, this allows me to not have this large container in the middle and use something called auto-resize, which will then allow the container to resize to the fluid that I need. So rather than trying to contain the whole motion path, I could contain it for one bomb each. So I'm going to resize this now smaller. In fact, I think I'll probably make that 555, just so I don't lose my fluid container. Okay, and as you can see, the squares on the bottom are now smaller because it's a smaller container, so our resolution goes a bit further. And what I'll need is for this container to move to where the bombs are dropping, because at the moment you'll see it doesn't do anything. So I select my fluid, and I want to select my nparticle 1 shape, and then again select my fluid. And what I want to do is I want to emit fluid from the particles. So select the nparticle 1 shape, make sure you've also shift select the fluid, go up to fluid, add edit contents, emit from object. What will happen when we do this is fluid will be emitted from our nparticles. So this will allow us to use those as an actual emitter to create that bomb blast. And it's come up with the default name here. I'm just going to rename that to primary blast so we know where we are. Okay, and if I play now, you won't see this container jump over here. In order for that to happen, we need to use the auto-resize feature, which I'm going to show you in a second. What I'll do first is I'll just show you why we're going to use this feature, and that you can do it without the feature. You can just resize the container like we did before to encompass the whole motion path, but I'll show you now why that's not probably the best idea in this case. Okay, you can see we are emitting fluid there, but it's a bit dim, so I'm just going to go to the fluid container, and I'm going to make that so you can see it a bit better. So I'll go down to the shading tab and just change its transparency and its color. So I'll make it black so it's a bit easier to see, and then I'll drop the transparency down a bit so again you can see it. And you can see here with this full size container we've got a very low resolution, and you know, this is never going to be a high enough res for what we're looking for. So in order to combat that, we need to turn the resolution up. So if I bung that up to 100, what you're going to see is our resolution goes a lot higher. You can now see our voxels here represented by this grid on the floor, but our simulation has seriously slowed down. And the point is, now it's calculating everything in the entire container when all it actually needs to be calculating is this small bit of fluid here. So this is where a function like auto-resize can really come into its own, because if we later then even decide to change the shape of the motion path, if we're actually using auto-resize, we would then be able to not worry about changing the resolution and the size of the fluid container and whatnot. So I'm just going to make this fluid container 5, 5 and 5 again, and set up the auto-resize so you can see the difference in speed that we have here. I'll just throw it out there to make it put it out of the way, and then go down to the auto-resize tab, hit auto-resize and leave that all at its default. If I then click go, you'll see that our container jumps straight to our bomb blasts. So we have this auto-resize now working quite well. You can see we have a few problems though, because it doesn't seem to be disappearing from this end. This particular lines of smoke continue on infinitely, so we need to tell these to dissipate in order for this to then be able to stop generating fluid, because we want a bomb blast. We don't want this equivalent of this giant piece of plume going up and up and up and up and up. But as you can see, our auto-resize did indeed work, and we'll work on getting this a little bit more accurate in the next parts. But for now, I mean, yeah, you can see each individual, well, they're not looking much like blasts at the moment, but you can still see each individual one go up. So I'm going to go back to the fluid container, and what I'm going to look for is under contents details, I'm going to go to the density, and I'm just going to turn the dissipation from 0 to 8. 8's quite a high dissipation, so you should start to see that smoke now dissipate straight away. And our auto-resize container is then doing a lot less work. You can see, you know, as these fall to the floor, they actually dissipate almost immediately. Now, a couple of problems we have with this. The first one being that this still doesn't look much like a bomb blast, and our auto-resize container is getting stuck down here in this corner. Now that we're going to work out in the next part, but you can see we have this dissipation going on. We have our secondary particle explosion that's become stuck here, and we'll go over why that's happened and how to fix it in the next part. And you can see our resize container is jumping. When we fix this, we'll actually get better auto-resize. So in the next part, we're going to cover how to start fixing that, how to get secondary fluid containers on this, and we're also going to look at not having that smoke come up straight away. So when the auto-resize container first jumps, we don't want the smoke to start falling right from the motion path line. We want it to start being created when it hits the floor, and we will cover all that in the next part. So I hope to see you for that, and once again, if you had any problems following along, please don't hesitate to ask in the forum. We're always there, and I'll see you soon. Hi, welcome to part 5 of our tutorial. In the last part we left off here with one auto-resize fluid container and a fluid emitter, which will be our primary bomb blast. So if we played this back last time, you'll notice a couple of things that have gone horribly wrong. The first one, and the most obvious, is that we have here what appears to be a stuck particle So our bombs are now dropping out and just disappearing and then reappearing here. Also, these start to emit fluid as soon as they leave the emitter, and we want them to fall to the floor for a second or so and then explode. So this stuck particle here seems to happen when you introduce one emitter to two or more fluid containers within Maya, or one fluid container in our case and one fluid texture 3D node. Now, there's a couple of ways around this, and in the case of keeping it simple, which we've tried to do with this tutorial, we're going to use the simplest one. What we're going to do is going to go up to the nParticle here, go into its shape node, and our lifespan at the moment is constant at 1.9. If we switch this to live forever, you'll see our problem here resolves itself. The only problem with this is that our particles now live forever, but you'll notice that our secondary explosion still happens in the right order, because when we designed our scripting for this, which you can find under the nParticle per particle array attributes, I'll just runtime before dynamic expression, when we designed our scripting for this, we went in and actually gave it an age greater than, less than, and greater than, stop all the emitters. So we weren't relying on the end of the particle lifespan to do the secondary emission. So when I said earlier that this would give us a little bit more flexibility, this was one of the things I was talking about. Now, there are other ways to solve this issue, but as I say, in the sake of keeping it simple, this is the one we're using for this particular tutorial. And as to our particles being left behind here, there are a couple of ways we can get rid of them after the age of 1.9, which is when they actually explode. We're going to take a look at that in another part when we introduce the live deformation to the ground plane as well. We'll have a clean-up part at the end of the tutorial where we fix any extraneous kind of issues like that. But for now, we have an auto-resize container. Whoops, I should play that forwards maybe. And you'll see it jump and automatically resize to contain the next blast there. Now, the reason it's stuck here in this corner is because our particles here are continuously emitting fluid. They emit fluid from the time they're born, and they keep emitting fluid, and they will keep emitting fluid infinitely, or until, in our case, till the end of 400 frames, which we have our simulation set for. Now, just the same way we used per particle attributes, per point attributes for our other emitters, so we used them on our secondary emitter and our EF hole emitter, we're going to need to do this as well for the primary blast. We're going to need to do this again so we can set in the script the rate for this emitter. So up to the nDynamics menu, nParticles, per point emission rates, and now you'll see if I go up to my nParticle shape, what I've got here is a primary blast rate per particle. So I'm just going to go runtime expression before dynamics, and here it is, nParticle shape 1, primary blast rate per particle. So I'm going to just copy that, and under the rate we set for the hole that's blasted in the floor, I'm going to also set this one to, we'll try 15, and then now I've turned it on, I'll need to turn it off. So what's happening here is the same with the others. While the particle is between 1.7 in age but less than 1.8 in age, it will emit from this blast emitter at the rate of 15. If it's older than 1.9, it will stop emitting from the blast emitter. So we can just go ahead and click edit. You'll see the result down there. You have to remember to click edit. If you just click close, it won't remember your changes. So if you do this and you accidentally click close, you can come back and do it again, and if you're getting a result you don't expect, you might want to go back and make sure you didn't just accidentally close it without hitting that edit button. So now when we play, you'll see here our particle is born, but it's not emitting any fluid. When it falls to the floor, it emits that one burst of fluid, and you can now also see that our auto-resize container is doing its job. So what we need to do now is take a look at this, because it's not very blast-like, it's just this tiny black poof of smoke. So the first thing I'd like to do is just increase the rate a little bit on the emitter, the density that's emitted. So I'll select the primary blast emitter here, and I'm going to crank this voxels per sec up to, we'll try 25. We'll need to probably adjust this as we go along, but just for now 25 should be a fairly good value. And now you can see we get, excuse me, now you can see we get more of a plume, a poof of smoke. So now we actually start to shade our fluid container here, our fluid within the container, and we're going to be using both density, heat and fuel. We're going to use the heat and fuel to get that nice primary orange blast. We're also going to use these particles, which eventually will be invisible, to have the explosion spread out across the floor a bit as well as going straight up. Now, one thing you'll notice, when I stop the simulation, it automatically goes back to the point light, which, as we're trying to shade the fluid, we're going to be here changing some details. We'll play the simulation to see what it looks like. We'll stop the simulation, and I'll automatically end up on this point light node. This again has to do with the mail scripting that we put in the runtime before dynamic expression. Now again, there's lots of ways to do this. This is not the optimum one, it is one of the easiest ones, and it does work, but that switching backwards and forwards between the point light while we're shading fluid is going to get very annoying very quickly. So for now I'm just going to comment out, which in mail is 2 forward slashes. This is per line commenting, so we won't actually be selecting the point light and we won't be transforming the point light. Now I'll click edit and close. I'll put that back in at render time. So, but for now, when I click this on, the point light will just flash here. It won't actually move. You know, which obviously is no good because we'd actually set this to be a point light where the explosion was happening. But just when I click stop now, it doesn't select me back to that point light. Which, while we're editing this fluid, we'll need to continuously preview this. So just taking that out of the mail script lets us you know, not have to fuss around going point light fluid all the time. Obviously if you want to put it back in at render time, you just runtime before dynamic and delete the comment section there. Okay, so now we get this small black poof of smoke, which is not impressive. So we're going to start with some basic shade of the fluid in this portion, and hopefully by the end of this lesson we'll have something that looks a little bit more like an explosion. We're going to spend a couple of lessons on shading this fluid to get the result we want. So right now I'll just simulate to a frame where you can actually see our... Okay, now select your fluid container. And what we want to do, before we start messing around with temperature and fuel, I just want to get this density to rise up in a big column of smoke. So first things first, we want to go to the shading node, and I made this black when we started at the end of part 4 of the tutorial, just so you could see it a little better. I'm actually going to now change it to a light grey, and you'll see this looks very flat and quite nasty. There is a couple of ways, and I'm going to flip this down to density as well. There is a couple of ways to shade fluid. In fact, there's more than a couple. We are going to use a fairly quick method in this tutorial, because the thing is, our camera angle is going to be over here when our blasts go off. So you're really not going to need hyper-realistic explosions. They're also going to be very fast. So if you can get away with a quicker shading of your texture, if it's for a distance shot like this one, then, you know, who's ever going to know, really. So we're going to flick down to the lighting tab, we're going to turn on self shadow, and you'll see that that's gone now immediately more sort of textured. What I'm going to do is untick use real light. This will it would allow you to have more accuracy in your simulation with real lights, but for our intents and purposes it'll slow the render down and we don't really need it. I'm also going to turn the shadow opacity up to 1, and then I'm going to make the shadows a little diffuse. I'm going to make the light color probably an orange. Very pale orange. Okay, and now when I resimulate this, you'll see a much more smoke-like blast already. So it's by no means perfect, and we need to do a lot of work on it, but you can kind of see already we sort of have more smoky sort of texture in there. Another thing I'm going to do is, although auto-resize is a great feature, and one of the nice things about it is, if we were doing this with a traditional fluid container that was wrapped around this motion path that we have, we'd be limited to where our aircraft or where our bombs could drop. With just having a curve here, if we pick it up and move it, and then I hit play, you'll see that the auto-resize container just comes to us. And because we've scripted everything, we've set no keyframes, we have no problem just picking this motion path up and moving it. Also, after you've designed this, if you want to do your own animation that drops bombs, I don't know, maybe something flying down a street or a completely different scenario to this, all you need to do is redraw another motion path in whatever shape you want, reattach your emitter to it, and the auto-resize containers will automatically jump to where your fluid is being dropped, or where your bomb is being dropped into your fluid. The only limitation you have is the size of this ground plane and the size of this 3D fluid texture node, but they can easily be resized. So using auto-resize allows you a little freedom. It's also much faster for something like this, so it's something to bear in mind when you're designing your next fluid simulations. If you can use auto-resize, you should probably try to incorporate that in your workflow. Anyway, just a small quick lecture there. And back to shading. Now, what we want at the moment with our fluid container is a much bigger blast. We want it to go up in the air much faster. So we go to contents details and density, which is what we're working with at the moment, and here you see the basic density attributes. Now the density scale we'll leave at 0.5. The buoyancy is how fast the fluid will rise, so I'll just do something insanely high here, 50, and then resimulate. I also set this dissipation to 8. It's by default set at 1, so I'll just click play here, and you'll see we get this great big billowous cloud, little too billowous, and you can see it seems to be blocked a little by our auto-resize container. This can be a bit of a problem with really fast moving fluids. If you just select the auto-resize container and you go up to auto-resize, you should be able to calm that a little bit by setting that to 0.001, and this sets the resize threshold of your fluid container. So I'll give you a better example. If I set the threshold to 1, you should see it clips the fluid a lot more. The fluid at this point basically needs to be very dense to make the container move. So the lower this is, the less dense your fluid needs to be. So as we're doing quite quick, in fact I'll leave this at 0.1, 0.01, sorry, because we're not actually just used this massive amount of buoyancy as an example of the buoyancy setting. We're not actually going to have a blast that's this big. Well, we're not for this tutorial. I mean, when you get through to making your own explosions and whatnot, you can then decide on exactly how big you want your blast. But for this particular one, I might set the buoyancy, I'll start it at 15 and we'll see how that does. That's still a little much. Again, we're going to need to set the dissipation up higher because I want these blasts to be gone by the time they would hit where our ship is flying around from. Otherwise we're going to have the ship blowing itself up every time it does a pass. So I'll put the dissipation up to say 8, and we'll resample and have another look at what that's done for us. So now we get fluid dissipate a lot more quickly. We have what looks like a small bomb blast. And one thing I would say, I think I was going to do this earlier on, is this auto-resize container, fantastic as it is a little bit annoying when you're simulating and you can see it in the viewport. Now we know it's working, we know it's doing its job, so I'm going to select the fluid one, which is this container, and I'm going to go up to display, and I'm just going to set its boundary draw to none. So now when I resimulate, you'll just get this, which makes it much easier to visualize what your fluid is going to look like. Now our fluid here is still a bit monotone. It's still a bit, if I take a render, you'll see what I mean. Oops, previous render open from something, sorry. You'll see this is not exactly what you call wonderful. It does have some shading and some shadowing, but it's sort of cone-like, and it's not what I'd really expect to see on a bomb blast. So we can sort this out to a certain degree, just very quickly, by throwing in some textures. So at this point I'm just going to texture the opacity. I'm going to texture, in fact I'll texture everything for now, we can take a look at that later on. And as I want my texture to move a little bit when the explosion happens, I'll just do a quick expression in the texture time. So if you type equals time times 1, this will now animate our texture. So if I get another render of this, you'll see here that that texture has started to break this up a little bit. I can get it broken up even more by upping the frequency, which is here. So if I up the frequency to say 5 and then re-render, you'll see here that I've got even more kind of smoke-like pattern. Now at the moment I should be on Perlin noise, which is pretty good for this. I'll probably end up using billow. Billow is nice for things like explosions, but it is computationally quite intensive, so your render will take longer. But then again, you know, you want a better look. You can see immediately here that this is a much better looking cloud of smoke. So you won't really see this in your render view, in your viewport. In fact, we can tweak a few things so our viewport looks better. I mean, already you see in that billow come in, but not as clearly as you would at render time. So in order to up the quality of this viewport view, what I'm going to do is I'm going to go up to display, should be up the top here, set the slices per voxel to say 6. The maximum is 12. The more slices per voxel you have, the better you're going to get your display here. If I just resimulate after that, you'll see it looking a little better. The fade out happens a little more naturally, and voxel quality I'm going to put on better. Now there is a couple of other things we can do to get this a little better. I'll just show you that when we have the voxel quality set to better. So you can see here that it's now quite easy to see what you're going to get in a render in the viewport, or it's easier, should I say. If I go to the dynamic simulation tab and I put high detail solve to all grids, this will also help us quite a bit with, you know, our fluid solve. High grid, all high detail solve is good for, you know, these fast moving explosion type of things. Also, if I want my simulation to be more accurate, I can up the sub-steps here. At the moment this is doing sort of, you could call it one calculation per frame. I can up this to, say, we'll put it at 4, and we'll put the solver quality up to 30. This will actually slow it down quite a bit. But as you can see, that's completely changed the nature of our explosion. So if I just put that back down to 2. Oh, it was at 1, but we'll see what it looks like at 2. You can see it doesn't go quite so high up. So again, this is another way you can use to play with your fluids. The higher this is, the more accurate your simulation will be. You don't necessarily, however, always want the most accurate simulation you can get. What we're looking for is something that looks good. So if you're trying to match a piece of footage that somebody's given you for TV and film, then you're probably going to want a very accurate solve. If you're doing something like we're doing here, the lower you can keep this and still get the result you want, it's probably better, as it will take less time. So another thing we can do to improve our quality, not just in the grid but in the render view, is to go down to shading. Let's skip past it, and there's a shading quality tab here somewhere. There we go. And if I put let's just get this on a frame so we can do a render. So if I do a quick render of this, you'll see here that this takes 10 seconds to render, and if I put the shading quality up to, let's go all the way up to 6, which is high, and then re-render, you'll see it takes significantly longer. So as you can see, it's a much longer process, more than twice as long. Now here we've got some issues with this smoke. If we go to our texture here, we can look at why we're getting this. Now at the moment we have a frequency of 5. If we turn this up to 10 with billow on, you'll see a much more billowous kind of effect. And I'll turn that shading quality down as well, I think. So we get a much more smoke-like feel already. And again, there is ways that this is not so good, where it's plateauing out. This is because the density is whooshing the fluid off the floor. There's no turbulence, there's no velocity swirl, there's nothing here yet to kind of mix this up, which we will look at adding in the next part. But for right now, I'll actually go ahead and just turn the shading quality back to 1. I'll also turn our substeps here. I think I'll just leave those where they are. Our slices per voxel I'll turn down to 2. And you can see it in the viewport. 12 is maximum, 1 is obviously minimum. And I'll leave the rest of these settings here. It's just I don't want to slow our simulation down. But if we look now at what we have, and what I'll do is I'll just drop the light back in its proper place. So I'll just delete these 2 lines here. Okay, I'm going to call this part quits. We've added some density to the scene. In the next part we're going to look at adding both temperature and fuel to get the actual explosion. We're going to look at shading this density as well, which we'll be using as the smoke cloud, so it kind of gets darker as it explodes and then fades away to lighter. And we will be concentrating on purely fluid shading within the next part. So I will now take a quick 400 frame render of this, and I will show you in the next part where we are so far. So thanks for watching, and see you soon. Okay, welcome back to part 6. Now at the end of part 5 I said I would take a quick render of what we have. So if you take a look at it, here it is. There's a couple of niggles. Obviously the particles are still alive. As I said, we'll deal with this in the cleanup phase. Our smoke is a bit grainy as it fades out, and the particles don't actually drop into the displacement holes. This is simply because we don't have displacement with construction history on our ground plane at the moment, because it increases the render time so much. And while we're doing this test rendering, I'd like to keep the render time as low as possible. Now also our holes here that are blasted in the ground might occur a little too slow, so we'll need to sort that out. We don't have any fluid on this secondary blast, and we don't have an actual bright fire spot where the initial explosion occurs. We will be sorting all this out over the next couple of lessons, but I think we're about an hour and 45 minutes into this tutorial so far, and what we actually have is deformations, displacements created at render time in the ground. We have some fairly nice smoke. We have 2 fluid emitters so far, 1 texture emitter and 1 standard fluid emitter, and we have 2 particle systems. So at the end of the last lesson I said I would continue by adding heat and fire to this, so we can get that nice fire feel to our explosion. But on reflection, I think we're better off sorting out our secondary explosion with these particles here, so our ground-based billow of smoke as well as our upwards billow of smoke, before we introduce fuel and heat, just so we can get a better look at the overall animation. So I will start with that now. Just close this down, sorry. And the first thing we need to do is add another fluid emitter for our secondary particle blast. So what I'll do is I'll just make sure I'm on the Dynamics tab. I'll go to Fluids, Effects, Create 3D Container. I'll select its options box, just make sure it's at default. It is. And apply and close, and you'll see here we've got another standard fluid container. Now what I'll do is I'll look at my fluid 1 and I'll just match it with that. I think it was 5, 5, 5 and 10. It is. So I will just do the same thing, size of 5, 5 and 5, and I will just whack W on the keyboard and move this over here. Okay, so now we have 2 fluid containers in the scene. You can't see the other one because, if you'll remember, I turned off its boundary draw. But if we just bring that back in under display, you will see boundary draw. I'll just put this onto bottom. So here we have our 2 fluid containers. This one is obviously doing our primary blast. So when I click go now, you'll see it's there. Just going to appear there. And when I did this as well for render purposes, I cranked the resolution of this 3D fluid texture back up to 50, sorry. I'm just going to whack that down to 10 to speed up our simulation a tad. So another fluid container, another particle system. So I'm going to select the fluid container here. I am going to select the nparticle here. Because our secondary particles use a different end solver, we're also going to have to select, instead of our particle 1, our particle 2. So up to Dynamics, make sure you're on there, and Emitter, Emit from Object. and again I'll just leave this as is, hit close and flick this onto auto-resize, because we will play now, of course. This one will automatically go to where it needs to be, this one will not. So I'll just click here and click our auto-resize tab. It should be at the top here, there we go. And now they should both, there you can see both of them. Okay, just see that again. And what I'll do, in order to shade this secondary emission and have a play with its particle attributes, because I'm not quite happy with the dispersion, I think, I'm just going to turn off this fluid container. So if I go up to its dynamic simulation and click disable evaluation, when I hit go now, you will just see the fluid from the secondary blast, and this is a nice way we can use to save on simulation time again. What I'm going to do is go back and turn off the boundary draw for this as well, so it's not in our way. So just to none, and again, if I just, you'll see just the contribution from the secondary blast now. Okay, so this is obviously emitting way too much fluid for us, and we don't want a very high buoyancy with this. What we want is it to spread along the ground. So first things first, what I'll do is change the buoyancy on the density. I'll also take a look at its emitter. So if I click fluid 2 here and just change that buoyancy on the density first, which you'll find under contents details, and I'm going to set a buoyancy of 0. Just for now, just for testing purposes, and take a look at what that's done for us. Okay, so we get spread out a lot more. We're going to have to script the dissipation on this as well, not the dissipation, the amount of particles released over time, because this is continuously releasing particles now, and that's not at all what we want. We're also going to make sure the fluid container itself is just set for just dynamic grid on density and velocity. Should be okay. Temperature and fuel off, as we're not using them at the moment. So again, we're going to need to script this. So what I'm going to do is go on to nparticle 2 here, sorry, and you'll see it has its fluid emitter now, and by now you should know what we're going to have to do. We're going to have to set the per point emission rates. So I'm going to click this, and now under our nparticle shape 2 node you should see the per particle array attributes, and here you have one for fluid emitter 1 rate pp. So if I go runtime before dynamic expression, we're going to have to create a piece of script here that will allow us to turn the rate on and off. So for instance, if same thing again, if I was to just put this in here and hit 300, you'll now see that our particles emit a lot more smoke when we simulate. They get a massive amount of smoke, way too much. So what we're going to need to do, go up to select filter, expression by name, nparticle shape 2. What we're going to need to do is just say if, and I will just copy and paste this again. Actually, what we need is nparticle shape 2 age is greater than well, we want this at birth actually, so what we can do is set the rate up here, and again I just copy and paste that, and then put an if statement here that says if it's greater than, let's just say 1 for now and see how we get on with that, then this fluid emission rate equals 0. So let's try this. Okay, let's just contain this here as well. else. And what we'll do is we'll just do a very short burst from this emitter. So we'll say emit while age is 0.1. Click edit. No errors in our script there. And we'll see this should just emit and then stop. There you go. So you can see 0.1, it's not even having time to emit out of all the particles. But we can tweak this value now, get it to 1 that we want. I also want to increase the speed on those particles somewhat. So if I go to the nParticle shape node and the emitter for it, and we should see here a speed attribute. So if I double the speed, we'll see what happens now. Okay, that's probably a little bit too much. Yep, that's definitely too much. So I have the problem here with my mel script and the point light again. So I'll just go to nParticle 1, runtime before dynamic expression, and I'll just actually comment that out again. Wrong way round with the comments, sorry. So now I've commented that out. I won't always flick back to this annoying point light again. And I want to select my nParticle 2, and here I want to do the fluid 1 emission rate. So this will be the emission rate for the fluid along our ground plane blast. And let's make this 0.8, and we're just going to go with the trial and error process and do this one by eye. Okay, well that's certainly given us an explosion out along the ground. So we need to look at this. This rate is way too high. I set the previous one on 15, and this will now not be dense enough, but we can take a look. Okay, let's go to our fluid 2 container and make sure they're all off. And what I want to look to is our emitter here. Maybe I'll turn this down to 0.5 while I'm just roughing out a basic shape. Okay, I can start to see individual trails from this shrapnel now. So I think because we're emitting from so many particles at once, we're going to have a pretty low density emission here. I'll try 0.1 even, and maybe we'll have to take the rate of particle emission down as well. Okay, that's starting to look more like it. Okay, so we'll fix some dissipation to this with a contents details, sorry, some dissipation to the density, because we're at a dissipation of 0 at the moment, which means it will just sit there, as you'll see. When it goes off, it explodes, but it doesn't dissipate at all. So what we want is we need to find a happy dissipation level. Let's try 5 to start with. Okay, now we're getting sort of a ground-based explosion. Okay, and now we'll just run through some quick shading. So once again, we'll go down to the lighting tab. We'll hit self shadow. We'll hit use real light to turn it off. We'll probably up this to 1, maybe even a little higher in this case, to 2, and put some shadow diffusion in there. 1.5 again, I think. Okay, so now we're kind of getting a nice groundward blast. what I don't want to see, I don't actually want to see these particles. If you wanted to at this point, you could instance some geometry onto them and make them actual shrapnel. But for this particular tutorial, I just want them to blow out across the ground, so I get an outwards plus upwards movement of my particles. And if I go to the shading tab, and make the transparency a little higher, and I'll probably make this sort of a lightish grey. Okay, now I'm getting a bit more of a smoke quality feeling to that. So again, this is pretty much what we did in the previous one. I just want to go down to textures. I'm actually going to change this to billow, and I want to texture everything again. And I'll use a frequency probably a bit smaller on this, maybe around 7. And now we can see what sort of effect this has had. Okay, that's looking kind of better. What I'm going to do is hide these particles now, because they're trying to sort of get in the way. So if I go up to nparticle shape and just push Control H, there we go. That'll actually hide the particle streaks we're using. So now what I'm going to do is, obviously I'm not happy with the shading on this, but I just want to see how it looks now in proportion to the bigger explosion that happens. So if we go up to display here, which is up at the top, it's quite easy to get lost in these nodes, and turn that off, and we also select our fluid 1, which is our primary blast, and turn the simulation back on, which will be dynamic simulation disable evaluation unticked. We should now get both fluids going off together. So you sort of get this one blast up and one blast out. Now I'm going to take a quick render of this and see what we've got. Okay, so I'm getting a different colour for a start. This is probably because I've used a light in. I'll just show you, it's probably quicker. So I'll select fluid 1, and if we go down to texturing, lighting, there we go. You'll see I have this orange light on here. If I just put this back to white for testing purposes and render, we'll get a much more integrated smoke. We'll tweak this when we come to the final portion, just to get a better look at it. But what I want to do now is just have another look at where we are so far. Okay, I think this bottom blast comes upwards too much before it goes outwards, so we need to take a look at these particles. So what I'll do is I'll select our particle shape and press Shift and H, which should unhide it. I'm going to turn off evaluation on both of the fluid containers for now, just to speed up our simulation while we play around a bit with our particles to get a better look for what we're trying to achieve. So yeah. Oh, there, it's dynamic simulation. Like I said, it's easy to get lost. Right, now we'll turn both of these off. In fact, what we'll do is we'll turn both of them back on, otherwise I'll be stuck with this cloud in the way, and then I'll go backwards and then I'll turn them both off. Okay, so now you'll just see I'll get the particle fall, and now I can have a look at this. I've got too much upward motion. I believe in the first part when we designed this we used an acceleration ramp to get more upward motion, but after seeing it with fluid on it, I think it's going to be better if we flatten it out a bit. So if I just go to our emitter here, which is E secondary, and I take a look under its basic emitter attributes, and what I'm looking for is the distance attribute. At the moment it goes up in Y, but not out in X and Z. So if I just set both of these to 0.5, we'll have a look if this spreads our explosion out a bit more. It does, but now it's going diagonally out and up, which is not the result I was kind of hoping for. So again, both of these to 0, and maybe just set this to 0.5. I mean, this shouldn't have a great deal of difference. It does not. Okay, I'll set that back to 1. We can try and achieve this with our acceleration ramp, which is probably the best way to do it. So what we'll do is we'll go into nparticle to shape per particle attributes, and while we have our ramp acceleration, we're going to edit this ramp, and we are going to set the color of it, and this is currently we need RGB. This is currently set for 3. If I make this 10, actually if I make this -3, this should spread our particles out in X and Z a lot more. It does, we get a much smaller jump. The other thing we can do is, as we're using a different nucleus solver for these secondary particles, just to tame this down a bit, damp it down a bit, what we can do is to actually go into the nucleus solver, which you'll find under the nparticle to shape node, and turn the gravity up to, let's say, 15. We'll try. Say we're just eyeballing this at the moment. Okay, so that gives me a shorter spread, and they don't go so much up in the air. What I might do is turn the gravity up to something quite high, like 25, and then use the speed of the emission to push them out a bit further. So again, back to E secondary, and under its basic emitter attributes, what we need is speed. So let's double this, see how that fights the gravity. Okay, well that's definitely spreading out a lot more. It's probably a little bit too much now. So again, we can just dial this down a notch and go to maybe 8. Okay, I think I like that. There's a little bump here, but it spreads out a lot more now. Because what we want is quite a thin ground blast that goes, you know, in a circular pattern outwards. So if we just go back and hide our nparticle to shape node with Control H, and we turn both our fluid containers on again, we'll have a look to see what we have here. So just untick disable evaluation on both fluid containers. And now we have a kind of much more natural looking explosion. We've got one that comes up in the center, and then this billow of ground dust that I like to see. So there's how we got both of our emitters to work in harmony. Now there's a timing problem here. The explosion disappears a lot before the ground dust, And what I'd like to do, now we've got both of these particle systems actually emitting fluid, is take another render of this. I'll take another animated 400 frames just so you guys can get an indication of where we are. And if I render this, you'll see now that the billow is set quite high, and this has given us problems with this fragmented look. So what I'll do is I'll take another render now, but at the moment another animation, should I say a render of an animation, but what we have now is both these particle systems working in harmony, and I just wanted to do that before we started to introduce the fire and the heat and the fuel and the actual bright flash explosion, because it's good to know exactly how big we're going to want this fireball in the center before we start to design the fluids even more. So in the next part we will actually get on to the bit you're probably all waiting for, which is the big boom, the fire, and I hope to see you then. Okay, welcome back. In the previous part I said I was going to take a render of what we had so far for you guys. So here it is, it's just the first 300 or so frames. And as you can see, we've started to define a basic shape for our explosion. It's not perfect, the timing is most certainly off, mainly because this top blast fades out long before we ever see anything fade out on the bottom one. There's also this nasty jump in the middle of the bottom one. If I can wait for a frame where I can pause it, you can see this big clump of darker, what looks more dense smoke in the middle, and I don't really like this. And the whole shape of the explosion needs quite a bit of work. I want more of a mushroom cloud sort of feel to this. Not exactly a nuclear explosion, because obviously these are a bit too small a blast to be a nuke, but I want the top and the bottom to come together, you know, so it looks like they happen at exactly the same time and they both fade out at the same time. I also want to slow this top part down a bit and give it more shape and more definition, and add some turbulence and some swirls so we can start to get better looking smoke as well. We're also in this part going to add the fuel and fire into the emitter, so we can start to, in the next part, then go and shade realistic looking flames and fire and explosion. So right, if we go into our fluid 1 container, and the first thing we'll want to do is just go under the fluid itself, and I want to the fluid emitter, which in this case is primary blast. And before I do anything, I want to just add some heat and fuel into this mixture. So I'm going to add a heat of 5 and a fuel of 10, and I tend to use a ratio here of 2:1 when I'm doing something like an explosion. I find it works quite well, because this will give us a lot of fuel to set fire to. So if we just arm these and press play, you should see some small smoke, some small fire effect, and indeed you're seeing no fire. That's because although we've turned on heat and fuel in our emitter, you still need to go up to your fluid shape node and make sure under contents method that temperature and fuel are turned on, and now you should start to see some flames coming through. There we go, you can start to see this fiery effect, but it's a little wimpy, for want of a better word. It doesn't look like a big bang here, and you know, I'm going to have to fix that. So what I want to do is back to the fluid shape node, and most of what we're going to do in this particular lesson is going to be under dynamic simulation and contents details. Now contents details is where you control the density, the velocity, the turbulence, temperature, fuel. So it's a very important section in the fluid node. So we're going to start off here by looking at this density. Now it's got a dissipation of 8. It's dissipating a lot quicker than this one on the floor, So I'll bring its dissipation down to 5, and we can check if the timing on this is any better. Now another problem we have is with this dissipation on 5, this is going to get slightly higher than I'd perhaps like, but the problem we have is that this primary explosion is huge. It's well on the way to almost have happened by the time this secondary explosion is tiny and is just, you know, pushing out the bottom part here. We'd expect these to happen in tandem. We could speed up the particle emitter that's emitting this bottom explosion, but then the particles would go further and we wouldn't get that sort of contained blast feeling that I'm after. The other problem is, if I just go up to our nparticle 2 here and make this visible again, Shift H, you can see, or you may be able to see, let's see if we can find an example of it. Maybe I'll have to get this a bit earlier into the reaction. Okay, the reason we're getting a clump in the middle here is because when these particles are emitted, you know, they're all emitted around one point, and that's going to take a lot of density and emit it all in the same place. Now, this is not really what we want, and also I say it's too slow. So what would be perfect for us is if these particles were born slightly away from the emitter. I'll just demonstrate. It's probably easier than trying to explain. If we go into the nparticle 2 here and go to the E secondary emitter, you'll see under here we have min and max distance just above the basic emission speed attributes. Now, if I were to give this a minimum distance of 0.5, this means particles will now be born 0.5 units outside of the emitter. So instead of being born here, right at the point of the emitter, they'll be born somewhere out here. This solves the problem of them all clumping together in the middle, and it also will make this faster. I'll just give this a max distance of, say, 1. We might have to tweak this a bit to get exactly what we're after, but if we just hit play, you should see now a much better timed explosion. There we go. This is much bigger. It doesn't clump up particles in the middle, and later on when we come to, and they both sort of fade out around the same speed, we'll fix the nasty looking fade out here when we come to shade this later on. Okay, we have much better timing between the top and the bottom now. Now, however, this is, you know, going way too high. It's actually too big now. So we'll go back to the fluid container, fluid 1 in our case. And now I have temperature in this equation. What I'd like is if the smoke stayed behind but the temperature went upwards in a big whoosh. So if I put the buoyancy of my density to, let's go as low as 1, and now you're going to get, you know, an explosion that almost stays on the ground. So as you can see, this is, you know, this is not fast enough to be an explosion anymore. So what I'm going to do is, we use the really high buoyancy on the density to push us up in the air. I'm now going to use a really high buoyancy on the temperature to help give us that same push. It's just I'll have the fire whooshing up and the smoke kind of hopefully staying behind a bit more. Okay, there we go. As you can see, it now reaches the top of the line again, but it's not really the defined shape I'm looking for. So I'm just going to go in and first off give it some turbulence. So I'll start with 0.1. Turbulence is a very strong value, so small tweaks will often do it. Swirl, I'm going to start off with, say, 3.5-ish. If you want to come in here and just round these values out, that's perfectly fine. Let's see, I'm going to have a little bit of diffusion, maybe 0.1, and I'm going to leave everything else where it is now. So now when I hit play, we'll see what that's done for us. Okay, I can see this nice flame coming up, and I'm getting good timing. I'm not getting the sort of poof large kind of fireball-like effect that I wanted at the top of what should be sort of a mushroom cloud shape. So what I'm going to do in order to give the fluid some cohesion, I'm going to use a viscosity of 1 and a friction of 0.1, sorry, not 1. And I'm just going to check this. Okay, so that's hanging together a little better. I'm turning the sub-steps back down to 1, and this should create a little bit more cohesion between this fluid. Actually, it's not the sub-steps down to 1 that will do it. It's now a much less accurate solve, so it will clump together by default. The higher the sub-steps, the more accurate, as I said in a previous lesson, the fluid solve will be. In our particular case, we don't want it that accurate. We're not trying to do anything that accurate. We just want a big puff of smoke, so it really doesn't have to be that accurate. So lowering this will speed up our simulation. It will also help it keep its shape a bit. Now, at the moment we're on a resolution of 10, which is extremely low for a container this size. This is why you're not getting, when I render this, I'll show you what I mean. Most of the detail here we create is simply in the fluid texture that we put in a previous lesson. So this is all fluid texturing at the moment. Now, it's unfortunate in Maya, or at least in some regards, it's unfortunate in Maya that fluid resolution, when you increase it, will actually change the dynamic behavior of the fluid. A lot of people will work with Maya fluids at lower resolutions, and then to get more detail in the fluid, to get a more photorealistic fluid, whether you're designing a smoke trail or an explosion, you up the resolution. But unfortunately, this will radically, in some cases, change the way that your fluid actually behaves. So if I was to rewind this and put the resolution to 20, you'll see what I mean. Instead of this long thin plume, now we'll get our more mushroom cloud sort of shape. So changing the resolution on our fluid there hasn't just altered the way that our fluid looks, it's actually altered the way it behaves as well. So remember that if you're working in low resolution fluids to speed up your workflow, then what's going to happen is when you change to a higher resolution, you're going to have to go down to your contents details, change a lot of your properties. Your fluid's going to need tweaking again, basically. So now we're getting this, and I kind of like this at a resolution of 20. I'm just going to push it up to 30, which should again even create a holding of that sort of mushroom cloud shape with the values we have in our contents details. Okay, one problem I'm spotting here is with the viscosity and I was going to say surface tension, with the viscosity and the hang on, let me just stop this because my Maya's going a bit. With the viscosity and the friction set at 0.1, it's helping us keep this shape a little bit, but it also slows everything down, and with the main buoyancy now coming from temperature and not density, the whole thing is slowed down. So I'm going to go on the simulation rate scale and up this to say 1.8 and just see what that looks like. Okay, I like the fact that these two reactions here are happening in parallel. Okay, I'm still not getting as much buoyancy as I'd like on the secondary explosion. This may be because my auto-resize container is clipping the fluid slightly. So if I go down to auto-resize, I'll set this at 0.05 and we'll try again. Okay, yeah, I think this is the auto-resize clipping the container slightly. But that's fine, that's another thing that's helping us keep this shape. It's getting a little bit higher up. What I'm going to do maybe is I will increase the buoyancy on this density also a little bit, just to try and get us a bit more speed and the upwards motion of the explosion. As you can see now, we're getting this mushroom cloud shape, and if it dissipates around the top here, okay, I'm going to actually take a render of this so I can start to see what it looks like. And that's an extremely large fireball. That might be a bit too large. What I think I'll do at this point is, now I think we've defined the basic shape of our explosion with our contents details, with our dynamic simulation, and also by changing the resolution of our fluid up here. We're now on a resolution of 30. So, you know, I'm getting quite happy with this shape. It definitely looks much more like an explosion. What I like to do at this juncture, as I said, is just take an animation of this, a render of 300 or so frames, just so we can get a handle on what this is looking like at the moment. And then when we come back in the next part, I'd like to start shading the smoke up a bit, shading up the explosion a little bit, and getting the look of what we want before we start to tinker around instancing geometry to our shrapnel to become rocks flying out of the ground and whatnot. So I will see you in the next part. I hope you've had no problems following along with this. As again, if you have, I'm always available on the SimplyMaya forum, and I'll see you in the next part for the shading. Thanks for watching. Okay, welcome back to part 8. In this part we're going to do some actual shading of our fluid, as well as probably tweak some of the things from the contents details section, like our temperature and density a bit more. If I play back our video of the frames that I rendered out, you'll see here we're getting a much more mushroom cloud effect. There is a couple of problems with it. It still fades out too quickly. The shading's a bit nasty. Smoke, I don't want this grey, I want it a much darker, blacker sort of colour. And this may be a bit too mushroom cloudy, and like I said, it does fade out too quickly. So we're going to start to address these issues in this part. So the first thing I want to do, actually before I start to do anything, the first thing I want to do is just drop some sort of environment here for us. Because when you're shading fluids, it's handy to do it against some sort of background, especially when I'm going for darker fluids. So all I'm going to do is put a sphere in here, scale it up, throw on a Lambert material, and under the incandescence I'm just going to map a quick ramp. There we go. I'm going to flick this to high quality so I can see what I'm doing. I won't need that. I'll move this down here. I'll make this probably black, and down here a light grey. Just sort of clock that, play it by eye. Okay, that looks fine. It's just sort of a generic background that I can work against. So if I hit play now, you'll see what we had before. Okay, my high quality rendering on this doesn't like it for some reason. Right, let's address this first problem. This is all fire and very little smoke. I mean, the bottom part obviously doesn't have any heat or fuel in it, any temperature or fuel in it, so this all looks still like smoke. But this fluid one that we changed has way too much heat now and not enough smoke, so we're going to go and address that. We're going to go back down to the contents details, which I'll find under the fluid one shape node, and there we go. There, lost it for a second there, sorry. And what I want to change is, if I look under this density tab, it has a dissipation of 5, that's probably too much dissipation. That's why it's fading out too quickly. So I'm going to change that to 2. I'm actually going to change its buoyancy right down to 0.3. I'm going to go under temperature, and I'm going to change the dissipation of the temperature to 2. And I'm going to leave the buoyancy where it is. So hopefully now the temperature will dissipate quicker than the smoke, so we'll see explosion, and then we'll be left with some smoke at the end of the explosion along with some temperature. Whereas before it was all temperature, as now you can see, it's, you know, the temperature is disappearing, and we are going to be left behind with a smoke cloud, which is what we want, not a fireball. So that's kind of sorted that out. And fuel, I want the reaction to happen instantaneously, so I want the fuel to immediately catch fire as soon as, like I said, sorry, immediately. So I'm going to change this reaction speed to 0, which means the reaction always happens, and the ignition temperature is 0, which means the ignition will happen regardless of temperature. And I'm going to add light released. This won't act as physical light. You won't see this as lighting up other objects in Maya. This is purely just a color thing. So I'm going to put this to a sort of an orange. So I'll go 14 4H 0.94 S, and I'm going to go 15 for V. This will look white, but it's not. I can assure you it's a super white orange color. Okay, so now when we play back, we'll see what we have. Okay, this is looking more like it. Temperature's fading out nicer, and this isn't dying off, dissipating quite so quickly. Okay, so I think we can actually do a bit of shading now. So under the shading tab, I'm going to make this slightly less transparent. There we go. It's a bit thick at the moment. I'm going to change the edge drop off to none, and under here I'm going to set the color to temperature, and I'm just going to make 4 swatches here. I'm going to put 1 at each end. I'm going to put 1 at 0.6, 1 at 0.601. Okay, what I'm going to attempt to do here is shade the smoke in this half of the ramp, and the fire in this half of the ramp. So I'm going to make this match this in terms of the number of swatches we have. So I'm going to put another swatch here and another one here. So I'm going to make this 0.6, excuse me, and this 601.601. Okay, so now if I make this black, okay, 0.6 please, there we go. So this half of the ramp I'm going to use to shade the fire, and this half of the ramp I'm going to use to shade the smoke. So for a start I'm just going to set this to white. Okay, and I'm going to set this to black, and this also to black. Okay, so this oh hang on, something's gone wrong. There we go. 601. Okay, this should also be white. So now again, smoke in this half, temperature, texture for temperature, color for temperature in this half. So start off with this smoke shading. I'm going to put another swatch in here, and I'm going to make this black. So you can see that my smoke here has gone a lot darker in color already, which is sort of what I was hoping for. So if I play now, I should get much darker smoke in the top part of the explosion. See, I'm getting a much darker smoke here, and then it's fading out to a light grey smoke. So I get a darker smoke at the start of the reaction and a lighter grey smoke at the end of the reaction. And because I've left this black and matched it exactly with this, it doesn't really touch my incandescent shading for the actual fire. So if I go back and take a render now, you can have a look at what happened. Right, if I take a render here at this frame, still shouldn't take so long to render, 10 seconds a frame maybe. And what we've got is we've got a lot of smoke, but this is the start of our explosion, so not a lot of incandescence. So what I'm going to do is I'm going to change these colors around a little bit. I'm going to put another swatch in. Okay, I'm going to make this end swatch black, and in fact I'm going to take out that swatch I put in, and I'm going to make this a super white orange color. So I'll just change the saturation to 0.9 and this to 15, I believe, and then I'm going to bias it this way slightly, and I can still see by this that we're going to have too much smoke still. In fact, if I just take another render, you'll see the colours have changed slightly, but there'll still be a lot of smoke. And you see how much brighter our fire starts to look now. I've used this super white orange combination, and we're getting, you know, some really nice detail in the fire pattern. But still, there's too much of it. So I'm going to bias the input bias of this up slightly, and you can see there on the in the actual viewport what's happening here. And so I'm biasing it up towards the flame and not towards the smoke. So I'll just take another quick render. And now you should see a lot more smoke, a lot less smoke, sorry, and a lot more kind of fireball type effect. So one other thing I want to just take a look at, shadow opacity. I'm going to bump this all the way up to 5. That will again help. I'm going to put an ambient brightness. No, I think I'll actually skip that, and I want to go up to textures. I don't really need to texture the color. Let's just check these. Okay, we're texture time, so our texture moves as well as our texture moves along with the fluid. I also want to make it to move from an origin, so in this case the Y origin, because I want it to go upwards. So you should see this incandescent start to fade out, and then a black cloud that gets lighter and lighter over time, and that's what we get. But I want this texture, I want to give it more movement, a bit more punch. So I'm going to take the origin on the y-axis and just go equals time times, actually I'll go minus 0.2. This will actually move the texture along the y-origin as the explosion occurs, so you don't get a repeating texture pattern. Just jumbles it up a bit for the eye, really. So there we go, great fireball. Okay, nice shading on the smoke, goes black and then fades to grey. Okay, again, really dark black smoke when this explosion occurs. And going up, the opacity should fade out and then go black, and then start to just fade to a lighter grey colour. Okay, that's kind of exactly what we were looking for. So all of this looks good, and I'm going to change the opacity ramp here a little bit as well, because I'm still not happy about this fade out. So I'm going to knock that down like so, put another point in here and just okay, we can kind of see what that did for us if I just zoom out here a bit. As you can see, our simulation is a bit slower now. It's not unbearable though. Okay, I'm kind of liking that. Kind of just fades out before the line, so that sort of makes me happy with the black to grey smoke blend. We've still got a big problem with this underneath smoke because now the two don't match. They should be roughly the same colour. So what I'll do is go to fluid 2, which is responsible for this smoke down here, and I can set a very high. Again, I don't need to texture the colour, thinking about it. Where are we? Lighting is what I'm looking for, which is under texturing, and I can set a very high shadow opacity, and that will sort of help us match that top smoke. And again, I'm going to do the shading the same way I did it for the top smoke. So I want one of these at 601, one at 6, and this one will be white, and this one will be white, this one will be black, this one will be black. I'm going to set this to temperature as well. There we go. That's not white. White. Okay. So what I'm going to do, because I'm not really going to have any temperature in here, I'm going to ignore this for the moment, and I'm just going to shade this smoke. So black. Okay. Now we'll take a look at that as it happens. Okay, we're still not anywhere near as dark as we should be on this bottom smoke here. So I'm just going to take this and make it a slightly darker grey. Okay, that should now start to affect our grid. I'm going to actually flick this to density, thinking about it, as I'm not going to be using temperature in this bottom grid. I can now just slide this up towards the blacks, and we will check this. Okay, I want to take a render of this and see if my smoke colours are matching up. Okay, they're sort of the same colour. I think we have not enough transparency in this one though, so we'll fade that down even more. That looks about right, and I just want to check the texturing settings. So we're not texturing this, so we want to texture time again. Time equals time times 1. So that will help us texture that, and we have a ratio of 7. I'm going to make it 10. And I think that takes care of probably most of the basic shading. We'll do some tweaks in the next part. We'll also look at instancing geometry onto our particles. So these particles here will instance actual rocks on, so we can get some shrapnel start flying about. But again, what I'll do now is I'll take a render so we can make sure we have no problems, and I'll come back in the next part when we'll look at sort of cleaning up our scene, instancing geometry, putting our spaceship vehicle thing in here to make the whole thing look a bit nicer. And hopefully in either the next part or the follow-up part of that we'll be finished with this. I hope you've enjoyed this so far, and I'll see you soon in the next part. Thanks for watching. Hi, welcome to part 9. Now at the end of part 8 I rendered out a quick sequence, And you can see here we're starting to get something that looks a little more like an explosion. I apologize for the scene jump there. Now I'm seeing a couple of problems with this, the first of which is this top reaction is happening a bit too fast for my liking, and there's not enough variation in this smoke, and it's not thick enough. I want thicker smoke with more variation of colour, and I'd like to slow this top part down. So the first things we're going to do in this part is just take care of that. So it's quite simple to do this. We select our fluid 1, which is the top part of our explosion, and if you scroll down to dynamic simulation, we can go here and turn this simulation rate scale from 1.8 to 1.5. That will just slow that particular top explosion down a little bit, and if I simulate this out for you now, you should see it's a bit slower and a bit more in sync with what's happening here on the ground. Because that takes care of the first problem. The second problem was I'm not getting enough variation in either of these smoke patterns, and this one on the floor is a little washed out. So we'll take care of the first one, and we'll scroll down to its shading. And what I'm going to do is I'm just going to pull this out a little bit, and you'll start to see we get more grey. Okay, I think that's about enough. And maybe I'm going to tweak the opacity up a bit. And I think there was a bit too much fire, so I'll just slide this input bias back towards the black, maybe 5.4. A little bit here will go a long way, so don't grab your slider and start going from one end to another. You'll get results that you're just not expecting. Literally 0.05 can make quite a bit of difference. The way we have this particular shading set up. So I'm going to resimulate that and see how that worked out for me. Okay, I can already start to see I get a bit more variation in colour. So I'm quite liking that. We'll do a final part to this tutorial where we will go and tweak this just to get it exactly as we want it. But for now I want to sort out this bottom bit so it's a little better, and I think for the bottom bit I'm just going to come in and turn the transparency down a little, and also just grab this and shove it out here a bit so get a bit more variation in that colour. Also select fluid 1, and I might just change this from a bright white to a light grey. I'm sure we'll come back to that in a subsequent part, but when I do the render at the end of this part, I'd like you to see a little bit of improvement, because I'm sure you're not sitting here listening to me just for fun. So what I want to talk about now is when we have this secondary explosion, it's supposed to be shrapnel coming out from the explosion. It's also supposed to represent some dust along the ground plane here. So these point particles we're using in Maya to generate this fluid, it doesn't look very much like shrapnel. It's not what you'd expect to see. You'd expect to see small rocks, bits of terrain, bits of grass, bits of whatever you were blowing a hole in the floor was come up and out. And to do this we're going to take these and swap them with geometry by instancing geometry onto them. So I've taken the liberty here of just grabbing a few rock-like objects, and if we hit import they're actually quite small, so I'll do a bit of a zoom in here, and you can see very, very simple objects just to represent some sort of rocky kind of debris that might come up from the ground, and maybe they're a bit small. Maybe I'll have a few small ones and a few larger ones, so I might change the scaling on this ever so slightly. And again, it comes down to personal preference. We'll show you how to get lots of little shrapnel, or maybe just a few large pieces of shrapnel. So what we'll do now is we'll select all of these, and we'll go up to nParticle instancer. This is what's going to replace our particles with geometry. So I'll just reset, just call it shards, and I want to click nparticle2 and click allow all data types. This will allow us later to deal with things like rotation per particle. So for now, however, that all looks fine. I'm just going to click create. Now, if everything has gone according to plan, when I play back, these objects here will have replaced our particles, but I've got a feeling that everything will not have gone according to plan, because on this particular version of Maya I'm using, it seems to have a problem where it forgets your initial instance of selection. So if I go here to our shards1 object and up to the attribute editor, you'll see instance objects, there isn't any. Now why it forgets I'm not sure, but it's not really an issue at all. You just control select here in the outliner or shift select in the viewport, however you prefer. Go back and click add selection, and you'll immediately see now that we have geometry in place of those white particles. So I'll hit play again. And you'll see here that when it explodes geometry. Now, we do have a couple of problems. It's all the same. We told it to use 3, but it's using 1. We're going to have to write a little bit of scripting for this to make it work. It's a very painless process. So what I want to do first is, before we get this to use all 3 of these, I want to sort out another problem, which is the rotation, because you can see these are not rotating, they're just pushing out along the floor. Now when it comes to render time, this is just not going to look very good. So first we deal with this rotation issue, and we do this by going up to the nparticle2 shape node, rotation, click compute rotation, and then down here you're looking for the instancer, geometry replacement. Now change the rotation to rotation PP. This is why we needed allow all data types here as well. So rotation PP, just make sure that's all set right. And now when I play, you should see that when they hit the floor they actually start to tumble about like actual rocks or debris would from an explosion. So if I just stop this here and select it so you can see the wireframe, you'll probably get a better look at this actually now rolling along the floor. But they are intersecting with each other as well, and this is also something I don't want to happen. So how we fix that is we need to go up to the nparticle2 shape node again, scroll all the way up to the collisions tab, there we go, and hit self collide. Okay, so now what should happen is they should be able to collide with each other, push each other out the way. You should see a much more chaotic explosion. In fact, if I stop that and select the geometry again, you should actually be able to see them now rotate in mid-air where they hit each other, and they don't intersect with each other anymore. And you can see the next lot. Now before we go any further with this, I actually think we've got way too much shrapnel happening at the moment. Again, it comes down to personal preference, but I'd like to see a bit less of this. So before we mix this up and add other geometry instances, I'm just going to cut the rate of this. So under nparticle1, scroll down to per particle attributes, select any of these, runtime before dynamic expression, and where we have the nparticle shape 1 E secondary rate, that's our secondary explosion emitter. We're going to change the rate from 600 to 300, and now when I replay we'll have half as much shrapnel as we did before. Okay, so we have much less of these shrapnel objects now, which I actually prefer. So now we have less shrapnel. What we want to do is we want to take a look at not having it all look exactly the same. If I was going to do this for production purposes, then I would most certainly be using more than 3 of these. But just for our little tutorial here, 3 is fine. You can create as many rocks as you like at home, and obviously the more time and effort you put into it, the better look you're going to get at the end of the day. But for now, 3 is pretty fine for us. And because also we're not designing one large explosion that's going to come under a lot of scrutiny, we're going to be having one explosion after another, explosion, 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 explosion. So you can get away with not being quite so fastidious about every detail, because it's more about the sequence of explosions as opposed to each individual one. So anyway, now we have this problem where all of these are the same object, and this is quite simple to fix. If we go to Fluid 2 and we scroll down to nParticle 2, and we scroll down to here, I need to add dynamic attributes, general attribute, per particle array. Make sure your data type is float, and I'm going to call this index pp, and I'm going to add. So now we have an index pp here, so I can creation expression. Now I'm just going to copy this, index pp equals, and what I want to do here is tell it to be random, basically. So rand, and I know I have 3 actual rocks, so I'll just go random 3, create. And now when I play this back, you should see that I have I think there's probably one more step involved in this that I've skipped in my hurry. Yes, as you can see, all the geometry is the same. If I click its wireframe view, it's all the same geometry, just at various different rotational points. What I need to do is actually go up to the nParticle 2, scroll down to the instancer, so here, and select object index to index pp that we just created. And as you can see, as soon as I did that, I don't know if you noticed that half of these went smaller and half of them went bigger. So now it's using this combination of 3 objects. In fact, if I just flick that off, you'll see it all go back to the same object. When I flick it on, we have this now nice instance geometry with 3 random, a selection of any 3 random objects. Now obviously, if you were to have, say, 10 of these rock shapes you'd created, or shrapnel shapes that you've created, you just need to go back into the nParticle 2 index pp that we created, creation expression, change this random from 3 to however many you have, and then go to the instancer and load it up with geometry. I mean, you can literally load this thing up with hundreds of different pieces of shrapnel should you want to. But anyway, now we have no need for this original geometry. We're using a shrapnel, so I'm going to hide this, Control H, and I'm also going to go up to the nParticle 2 here and hide its shape so we don't see those white point particles from Maya anymore. So now you have a collection of various different sized debris coming off here that all rotates when it hits the floor. You should be able to see it tumbling around there. And if we have one piece here, a static piece here, they'll actually collide with each other and move each other out of the way as well. Just adds a little bit more realism to it. So now we've got our shrapnel and we've got our blast. One last thing I'd like to do before I end this part and go away and render it out so you don't have to, is I'd just like to bring in the TIE Fighter object that I am using to drop these bombs. I mean, you can use anything you want. Like I say, I just picked this TIE Fighter object because it's a nice, simple little object. So here you go, and now all I need to do is attach it to this motion path. So I select the TIE Fighter object. I will then select our motion path, which is our curve here, and under the animation menu I want to go to Animate, Motion Paths, Attach to Motion Path. Now as you can see, this is not attached in the right way, so if I select the curve here, Motion Path 2, Motion Path 1 is the settings for the emitter, and I want to change the front axis to probably Z. Let's just make sure that's orientated in the right way. Play it to make sure it's okay. That's perfect. I'd also like it to tilt so it banks as it goes around a corner, and it's a very simple way to achieve that. I'm just going to select Motion Path 2, put a front tilt of 0 and set a key. Actually, I think I'll put a front tilt of -5 so it starts out slightly tilted, and set a key. Let's just jump to the end frame here and set a end tilt of -35 and set that as a key. And now when I play, you'll see this start to bank around the corner. And I'm just going to stop this and take a test render. Because we've lowered the number of particles that are actually emitting this bottom fluid, we might also need to add more fluid density into this. So let's just have a quick look at this test render. Actually, it looks alright. You need to see it rendered, but I get the feeling this is going to be just fine. So, and I think maybe we dropped the amount of fire here a little bit too much. So as I said, when you're working with this setup that we have here, small changes can make a very large difference. So back up to our fluid 1, and under the incandescence, maybe set this at 5.6, and I think that should do it. Maybe there's not enough transparency now. Maybe we put too much in here. Fade out a little bit. Yeah, I'm just trying to get a shape I like. Try that again. Okay, one other thing I wanted to do, I just wanted to give these shrapnel particles ever so slight bounce. So nparticle 2, of course, and I think just when they hit the floor, if they had a nice bounce and tumble, this could look quite good. So I will go up to collisions and set a bounce of 0.2, and we'll just play this. And we'll see how much they bounce. So they kind of skip along the floor a bit. Okay, I think that's about good enough. Another thing you might have to do is go to your nparticle 2 here, where we are, scroll up and make sure the lifespan is set on live forever. I think on a previous tutorial we actually set it to constant, which would mean they would disappear after a certain amount of time, which was fine when we had those little points, but now we have actual shrapnel. It would be quite nice if they, didn't disappear. You want your shrapnel to stay on the ground. So there is our small TIE fighter, our shrapnel, and our instanced geometry. So I'm going to keep this part quite short. In the next part we'll take a look at some scene cleanup. We'll take a look at having all of this geometry fall into the holes that we blow in the floor, which will again make the whole thing more interesting. And we'll be looking maybe at some final tweaks and the final render settings to get the same result you saw on the introduction video. So thanks for watching, and I hope that didn't go too quick. Again, you can always find me on the forum over at SimplyMaya. Cheers. Hi, welcome to part 10 of our tutorial. This should be the last part of our tutorial. I took the liberty at the end of part 9 of rendering out a few frames here so you can see what we have. Now if you've been following along, this is what you should have. I apologise for the render quality. The reason for the jagged lines here is because I'm rendering with no anti-aliasing, just for this quick test render. Now I was quite happy with the explosions on this. Could possibly use some more work on the shading of the smoke and fire, but overall this is the effect we were going for at the start of the tutorial. Now we are still having some problems, the primary one being that our bombs don't disappear, and also neither do they fall into the holes. You'll notice that our shrapnel here is sitting on top of the holes, it's not actually falling in. So this is a bit of a problem for us. The reason for this is displacement is calculated at render time. So until you come to render, the simulation won't know that it's supposed to drop into the hole. In fact, if we take a look at our ground plane here, it hasn't deformed. So even when I go and drop a bomb on it, the geometry remains perfectly flat, which means the next bomb that drops can't roll into the hole that's there. Now we know the hole is there because we can see it on the render, but again that's displacement calculated at render time, and what we need is displacement calculated in real time. So we're going to show you how to do that now. It's a new feature for Maya 2011, so if you're following on something that's older than Maya 2011, I'm afraid you're not going to be able to do this. One way around it could be to throw your shrapnel further away from the explosion, but you know, with this new feature we're going to be able to do a bit better than that. So let me just get rid of this window, and what I'm going to do before I start is just go up to nparticle 1, and when I re-rendered this animation I actually turned this point light back on, so I'm just gonna flick it back off to stop it being selected every time we play the simulation. So we want to turn this plane into a displacement reconstruction history, you know, instead of this standard polygon which is not capable of being deformed. And then what we want to do is our displacement map that's being generated by our fluid 3D texture, we want that applied to this geometry in real time to actually deform it. So before we get around to making this a displacement, I'm just going to give it some more geometry to work with, because you know, when we displace this it's going to need more subdivisions to get a more accurate displacement, and the higher you go with these subdivisions the better your displacement is going to be. But again, for us in this there's a point of diminishing returns. The higher you go, also the longer your displacement takes to calculate, and with that length of calculation comes, you know, slower simulations, slower rendering. The whole process slows down. It means your test renders will be slower. It means you probably won't be able to get the tweaks in that you want. And to be honest with you, at this kind of level of geometry, unless we zoom the camera right into the hole, then this is going to be fine. If you're doing this and you're going to do some close shots of the explosion, some close shots of the hole, you might want to take the geometry subdivisions up a little bit to give you more geo to play with. But for this, should be fine. So now we have this, what we're going to do is we're going to go up and we're going to modify, convert displacement to polygons with history. And you'll see that our geometry gets triangulated. This is in order for Maya to be able to calculate it when we apply these live displacements. Another thing I'm going to have to do is our nRigid, which is the passive collider for the original polygon plane, will still be set to that original polygon plane. So even though I can click play, and you'll see this, it's rather cool, it will actually deform this terrain in real time now based upon the displacement map generated by the fluid texture, which is one of my favorite features in Maya 2011. And there's something else I want to mention here as well. You saw what we got there was our bomb hitting the floor and then bouncing up in the air like it had a lot of bounce on it. Now this only seems to happen in Maya version 2011 without the service pack on it. With the new service pack they seem to have fixed this bug. As I said, this plane displacement was a brand new feature for Maya 2011, and it does seem to be a bit temperamental sometimes. It's not really a huge problem. You can just click rewind and resimulate, and that simulation error should go away. It rarely happens, so it is something to be aware of. If you start to see some weirdness in your simulation, it probably has to do with this new feature. But now you see we have no error, and the great feature is that it's actually displaced this terrain in real time. Which means that the next bomb that's just dropped on the floor here should be able to roll down into this hole. But it can't. Now the reason for that again is this nRigid here that's still set to the original poly plane. So this was the problem I was talking about. We need to get rid of this. We need to select the displacement now to be used as the passive collider, and then when I click that, I've got an nRigid that's linked to this displacement plane. So now when I play, I'll just let this simulate again. And you should see when the first bomb goes off, it makes the hole. The first bomb will drop into the hole, and the second bomb will also roll down into the hole. Okay, let's just stop that simulation and change the angle on this. And you'll see already that the first bomb is below our horizon line of our geometry here, so that has dropped in the hole. And in the final render we'll get rid of these bombs once they've exploded, but just I'm going to leave them here now as an example. And you know, this one hasn't exploded yet, so you'd still expect it to roll down into the hole before it explodes. And as you can see, it's rolling down into the hole quite nicely, and it explodes and causes live destruction of geometry. Now we still have some work to do on this, because although it's working with our primary particles, you can see it's not working with our secondary particles. With our instance geometry is not falling into the hole. Now this is because the way we set this scene up, our primary particles, our bombs here, use a nucleus solver number 1, and our secondary particles use nucleus solver number 2. And this nRigid is only linked to the first nucleus solver. So of course these particles look like they're bouncing off this plane and ignoring this hole, but actually they're not. If we look under our nucleus 2 solver, you can see that we have under ground plane use plane ticked. So this nucleus 2 solver is actually using a fake ground plane. So if I tick that off, our shrapnel will now fall straight through the floor. Sorry about the simulation time, it's just when we're using quite large fluid. We're actually using very small fluid resolution, but it's enough resolution to slow this down, and when we're using this live displacement here, you know, it becomes a bit slower to simulate. So you should see now that our shrapnel will just pass straight through the floor. That live displacement is just great. I really like that feature. But anyway, our shrapnel fallen right through the floor. So what we need to do is we need to somehow either connect this nRigid twice to this piece of geometry or make another nRigid that's linked to the second nucleus solver. So we'll select our geometry, we'll go up to nMesh, and you'd expect to be able to go create passive collider, use nucleus 2 and make collide. Now you would expect that to work, but you'd be a bit disappointed. You'll see we still have one nRigid shape connected to nucleus solver 1. Maya really doesn't like to assign two nRigids to one piece of geometry. So what we need to do is we need to give it a bit of a kick, and we'll just duplicate this. So we go to Edit, Duplicate Special, and we want to make sure Duplicate Input Connections is ticked. So now we have two nRigids, but they're both linked to nucleus 1. And we want to link this one to nucleus 2. So you're probably thinking now we go to nSolver, Assign Solver, nucleus 2. And you think, aha, cracked it, easy enough. Now two nRigids, both linked to the displacement plane, one to nucleus 1, one to nucleus 2. If we simulate though, again, you'll be a bit disappointed because your shrapnel particles will still drop straight through the floor. And we're getting that weird simulation artifact that you get when you use this plane with displacement on a version of Maya without the hotfixes installed. So I definitely recommend you download the hotfixes. I'm using Linux at the moment. I haven't had a chance to download them yet. But there we go. So even though our nRigid is linked to nucleus 2, our shrapnel still goes straight through the floor. That's, as I said, Maya really doesn't like to do it, so we're going to have to force it to make the connections manually. Luckily enough, it's easy enough to do. We go to Window Connection Editor, and what we want is our nRigid shape node loaded in on this side. So reload left after selecting that, and we want to select our nucleus. So I need to untick DAG objects only and find our nucleus 2 solver. There it is, and load this in the right. Now I want to connect nRigid shape 2. I want to connect the start state to the input passive of the nucleus solver. And you'll see here, as soon as I click result connected. And I also want to make one more connection, which is the current state to the input passive start. So again, I click current state to the input passive start. And this has finally linked up our nucleus 2 solver with our nRigid 2 with our displacement plane here. I'll just and again, I apologize for the simulation errors. They should not happen to you as long as you've put the hotfixes on. Does seem to be a bit of a bug in 2011, but it is a great feature, and I think a little bit of resimulating takes a couple of minutes of your time. I think it's well worth it to use this great new feature. But now we should start to see that our, let's just freeze this at a frame where I can actually see this, and I'll select our instance a node, and you can actually see now that these are dropping rather nicely into the hole along with the bombs. So now when we do our final animation, our final render of this, not only will you get the bombs drop in the holes, you'll get the shrapnel drop in the holes. When new bombs go off, shrapnel will be capable of moving old shrapnel out the holes. You'll get a lot more interaction and a lot more realism, and just an overall a much nicer effect. Now, as I'm having a look at this, we do have one problem. Our geometry is away from the floor here, so that's a bit of an issue. We are getting the correct collisions because it's all the same distance away from the floor, but it is away from the floor. Our bombs are also hovering a little bit. We can take care of this quite simply. We'll just rewind this and go up to the nParticle 1 Now if we look under its collisions, you'll see this collision width scale. I'm going to change this to 0.2. And I'm going to play. And again, apologies for the simulation time, but I will stop this one when it's on the floor. Okay, that looks like it's bisected a little bit. It has. So I will put that at 0.3 and call that good enough for our purposes. I'll set the shrapnel to the same collision width scale, 0.3. And that should be good enough for our purposes here. We're never really going to get the camera close enough to the ground plane for anybody to be able to see if that's, you know, the 1/10 of a millimeter out. So again, I think I'll just call that one accurate enough. If you're doing this at home, then obviously you might want to spend a bit more time dialing that number in to a value that's a little bit more exact. I just don't want to waste your time here resimulating 26 times so I can finally get it to a value of 0.2816. I'll let you do that, and I think if I just stop the simulation, I can actually see that even without extra tweaks, that geometry for me is on the floor. Unless I get the camera kind of here, no one is ever going to know that we're not completely accurate. So in this case, that looks like that's fine. So now, again, we have pretty much exactly what we set out to do. When I render this out now, you've got those live deformations happening, with the shrapnel capable of falling into the holes, the bombs capable of falling into the holes. We've got everything we want, really. Before I go for the final render, there is a couple of things that I would do. I would double check my settings. I just want to make sure I have no bounce on here and a little bit of bounce on here. I'd also go to my fluids and change the shading quality from 1 to maybe up to 3. I'd have to do some test renders, but 1 is probably a little low for a final render, so I'd bung that up to 3. If I'm rendering with mental ray, I'm going to want to turn off the jitter, so I'll just put that to adaptive. The render interpolator to smooth, because that gives a better result at render time. And of course, I'd want to do the same thing with this fluid. Go to adaptive, go to linear. I might also adjust the amount of shrapnel I had, and I can do this by going to nparticle 1 and any of our runtime before dynamic expressions. Here our E secondary is the shrapnel emitter. It's the one we have this instance there linked to. So if I change this from 300 to 900 and click edit, and then I just want to play the simulation, you'll see that we get a lot more shrapnel now. So that's something you can tweak for your own personal preference. You can also go back and look at the objects connected to the instancer. Maybe you want larger shrapnel, more variation between small and large. You know, you can, again, as I said in the previous part, link more varied rocks or blast debris into that instancer, also with different sizes. But as you can see here, we now have a lot more shrapnel created. I would also, before the final render, go into the fluid, and I'd probably have a look under shading. I might introduce a bit more variation in my smoke color. And I think that's about it, really. That's pretty much all I would do for the final render, apart from upping the render quality, of course, to get rid of these jagged edges and just to give us a bit more overall quality. I might go to fluid 2 and then go to the fluid emitter, and I might even chance a little bit of heat and a little bit of fire in with the shrapnel, so I get a slightly bigger blast and tie the two together a little bit more. Before I actually set that off, I will go and give me less shrapnel, because I actually quite like less shrapnel. But again, it comes down to personal preference. Whatever you think makes look makes for a good explosion in your particular scene. And now when I do this, I'll get some smoke and fire in the shrapnel, and before I do that, I just need to check under the fluid to shape node that temperature and fuel is turned on. It's not. So remember that even though you've gone and turned on heat and fuel in the fluid emitter, you still need to make sure it's turned on in the fluid container, or you're going to end up trying to debug a problem that's not actually there. It just needs to be on in two places. That's just something that might save you some time. Can't say I haven't done it myself. Okay, and now we should see just a little hint of colour in the bottom explosion as well, kind of giving us an orangey sort of look. It's quite subtle. You can just see certain shades of orange in this bottom smoke as well, and this bit that connects the two is now a lot more orange. So I personally think that will give us a nicer render, along with the shading quality that we've upped here under shading quality. And that's about it, really. That's pretty much what I wanted to take you through in this tutorial. Wanted to go through multiple particles being emitted via the use of some scripting to help you get your timings down right. Wanted to do multiple fluid containers. Wanted to show the 3D fluid texture node, and that we could use it not only to become a displacement map but also a transparency map, and use it with this layered shader to make these nice holes in the ground, and then use that again with a displacement node to make this new live displacement feature happen, which is a real plus for things like this, because now we can have particle interactions between displacements, which is a very nice feature. I wanted to show you connecting a couple of these n-rigids to this one ground plane, and then using two n-solvers to create this overall effect. And I think we can conclude this tutorial here. I really hope you enjoyed following this along, and I hope we managed to show you some things you didn't know before. I hope you learned a bit. If you do follow this through and you'd like to post your work, we'd love to see it on SimplyMaya. We'd be happy to give you feedback or any help you might need. And I hope to see you in the next series of tutorials we make, which will be dynamics again from myself, and this time we'll be dealing with liquids and things like seas, rain pour, wine pouring, and things like that. We'll be dealing with liquids with Maya fluids. So I hope to see you for that one, and I'll be back in a second with a video of the final render that I got. And yeah, see you around the site. Thanks for watching. Hi, welcome to part 11. Now, in the last part we left off here, where I said we'd probably finish this. I'd just come back and show you the final render. As I was rendering out, however, I did remember that I'd forgotten to show you how to make these bombs to disappear when they actually explode. And as I got to looking at this for the final render, we've come quite a long way in this tutorial now, and I'm happy with the bomb blast. As I was doing the final render though, I'm not happy with the roll of these particles, these shrapnel objects, nor was I happy with the size and variation we'd managed to get. And it's something to come to this, but it's grey and it's kind of dull, so I came up with this for our final animation. And in this part we're going to discuss how we go from this to this. So as you can note, we've got some better size and variation in our shrapnel here. We've got a slightly better shaded bomb blast, although this one is actually pretty good as well. And our bombs disappear after they explode. So we'll get straight on with this. And the first thing I want to do is, these were the rock objects that we used for our shrapnel. I'm just going to get rid of these, and I'm going to import a new batch that I made. So here we are under rocks, group 1, and I made these simply by taking a polysphere and then using the sculpt geometry tool just to push and pull around in it. And I'll just unhide these, so Shift H, and you can just see that these are just polyspheres that have been pushed around a little bit. What I'm also going to do is, while I've got them unhidden, is just assign a default material to them. I'm just going to assign a straight Lambert to them. For now, we'll look at shading them in a minute. So I'm just going to go ahead and re-hide those. So Control H after shift selecting them in the outliner, or Control selecting. Now, if we look under our instancer object, you'll see there's no geometry in it now. So if I simulate, I won't get any shrapnel because we deleted the old rocks that we had. So rather than making you wait for that, you can just take my word for it. I'm going to select all of my new rocks, and I'm going to go Add Selection. Now there is one more thing we do, because previously we only had 3 rocks and now we have 5. We'll go up to the nParticle 2, under the nParticle 2 shape node, per particle array attributes. What we need to do is go to our index pp expression that we made, creation expression, and tell it to select random 3 to random 5. We go to edit, and you'll see result nParticle shape 2. If we just play this back, you will now see that we get a random selection of each of these 5 particular objects. You'll also see that this is going to be way too big for our purposes. Now, there you can see there we have our 5 random objects. If I just click here, you'll see we get different shapes, but we get all the same size, and we have that bisecting the floor issue again, but that's not a problem. We'll just look at that in a sec. So the first thing we want to do is sort out the size of these, and also if I let them roll, again I'm not so happy with the roll, so we're going to sort that out as well. So we'll go up to nParticle 2 under its shape node, and I want to look under the instancer node here. So at the moment the scale is set to the scale of the object, and I want that to be set to radius pp. So let's have a look here. Okay, we don't have one, so we'll have to go and create one. So under Add Dynamic Attributes, hit General, under Particle, you should see here a radius pp. There it is. Click Add. Okay, now we have a radius pp, you can see here. So back down to the instancer, and general options, back down to the instancer under the particle shape node. General options, scale. You should now be able to set this to radius pp. Okay. Where has it gone? There we are. Just allow all data types. Okay, now if I play, you'll see we've got different size to these particles, these shrapnel objects. And there we go. Now we have this tiny shrapnel. But again, even though these are different objects, they're all the same size. So what we can now, because this is now controlled by the radius pp, we can go up, and under particle size we have a radius of 0.2. If we make this a radius of 1 and hit play, you'll see now these get bigger because they're being controlled by this radius scale. So what we're going to do now is find the maximum size that we want these. Okay, so that is probably as big as I'd want these to get. So go under radius scale. So now I've got my maximum position. If I set my radius scale input to randomized ID, what this will allow me to do is build this ramp here. So if I open a larger one, and I'm just going to click, and this will give me another point on the ramp. Now if I were to do this, this would mean that my scaling would go from 0 here to our maximum here. So if I just simulate with a ramp like this, you'll see, or hopefully see better, what this will do for us. But basically it will give us a random scale between 0 and maximum value up here. So we'll get a whole different collection of rocks. Okay, there we go. You can see we've got some extremely small ones here, some large ones, and everywhere in between. Now personally I don't want this much variation, so I'm going to crank up the minimum value to say 0.35, and this means I won't get any rocks, debris created that's smaller than this, and my largest ones will be slightly smaller than our maximum selected value. So let's go ahead and take a look at that. Okay, we've got quite a good differential in size. I can see some medium ones here. I can also see some tiny ones here. So that seems to be about what I was looking for. I'll just go ahead and let the next one go, and we'll see what we get for variation there. Yeah, and I can see I'm getting a good variation. So I'm happy with this radius scale ramp we've drawn here. You can make this complicated. You can put spikes in this to get a few larger ones, or you can add as many of these points to sort of define your grid, your scaling ramp here, however you want. But for our purposes on this one, just this kind of setup is going to do us just fine. So excuse me. The next thing I want to sort out is making our particles here disappear, and as I said in the previous part, I just want flat matte black bombs. I don't really want this shiny pink bombs and blue and purple and whatnot. So what I'm going to do is I'm going to open the hypershade. Okay, and I have here the default shader. So we can see here color, it's all linked to the particle attributes. Because I don't need this to be linked, I'm just going to break its connection, and I'm going to make the color of these sort of a dark matte black. I'm also going to turn off the specular highlights because I want a matte. So, and I also don't want reflective bombs, so I'm going to turn all this to off. And so this will give me the matte black color I was looking for. What I want to do though is make them disappear when they explode. So this is quite simple in this case. We'll just go to our nparticle 1 shape. We will go under any of these, runtime before dynamic. And what I'm looking for is the opacity PP. So actually I'll click this one and break its connection, and then runtime before dynamic expression. What I have here is nparticle 1 shape opacity PP. I'm going to copy that, Control C, and I'm just going to paste it under if our age is greater than 1.9, the opacity equals 0, i.e. it's transparent. So what will happen is We'll let this play through. When this explodes, i.e. when its lifetime is more than 1.9 old, it will go fully transparent and disappear. Because we use two particle systems under nucleus 1 and nucleus 2, it will still be there, it will be disappeared, but it won't interfere with our shrapnel because they use two different nucleus solvers. So let me just simulate that for you. Okay, as you can see, we've got our nice variation in rock sizes here using radius pp, and we also have better rock roll now, I believe. We're using that radius pp instead of the individual geometry scaling. It's allowing Maya to calculate the roll on these rocks a little better. And as you can see, once our bombs have exploded, they've actually disappeared. You can still see the outline of them because I'm on the nparticle 1 shape node, but if I flick that off, you can see they've actually disappeared. And the same will be true of this one. When the bomb goes off, this will disappear. Now we've tried to in this use very simple mail script, but you can come in here and play with the mail script to get better timings on the explosion and whatnot. But from the distance we're going to be shooting this from, this has worked out just fine with me on my final animation. Now another thing I wasn't too happy about was the distance the actual shrapnel was thrown. So this is easily to sort out by selecting nparticle 2 and going up to the emitter here, so that would be E secondary 1, and over to its speed. So I'm going to put the maximum speed at 12, but I'm going to give it a speed random of 3. So this will then be either 15 or 9, it can be anywhere in between. It's just random 3 either side of this value. So then after you simulate again, you will see that we get some shrapnel thrown further, some shrapnel thrown the same distance as we had before. Just it's a way to get some random variation in your shrapnel speed. So you could want more random variation than that. That seems to be, you know, we don't have many falling in the middle anymore. So if you were to put a random variation of say 6 in, double that, make this slightly slower. So this will now be anywhere from 16 to 4. And we replay that. This is really something you're going to want to tweak depending on the background plate you're going to use and your final animation. You know, I'll let you decide this. You might want the shrapnel to just blast off into the stratosphere, but again, that's something you'll have to decide in your particular animation. Okay, but for me and the purposes of this particular tutorial, this looks pretty nice to me. I get some left in the hole, I get some interaction with that deforming geometry in real time, which is nice, and I get, you know, quite a nice blast range. I've got one that's rolled over here, a few that have stayed over here. Right, the last thing I want to look at is sorry, let me just bring up the right window. Okay, the last thing I want to look at is putting this background plate on and doing a little bit of smoke shading for the final effect. So for the background plate, we're going to do this purely in Maya. If you were to render out passes and comp it later on, this would also be probably the better way to do it, but I wanted to keep this tutorial all in Maya. So first things first, we're going to get rid of this environment sphere we originally created because we don't need it. We're going to use, let's say, that backing plate, and what we are going to do is select our camera here, So at the moment we're using perspective. I'm going to go ahead and create a new camera. So cameras, camera, and then I'm going to flick over to our camera view, and then I'm just going to get a good position on this. Okay, it looks about right. And now I need to put a background image to this camera. So if I just click here, I'll select the camera 1 shape node and scroll down to environment, image plane, create. And I'll have to give it an image file. Now I've gone ahead and used this one. You can see here it's just a standard PNG that I've blurred the background slightly to give an impression of depth of field. Okay, and you can immediately see this appears in my viewport. If I go to shading, X-ray, you'll be able to see through our ground plate, and you can see that our ground plate is not really matching up with this image here, so I'm going to match that ground plate a little better to the background. You don't have to be perfect with this, it depends where you want your bombs to drop, but you know, if I have my background plate here and a bomb drops here, it's going to look like it's exploded in midair. So I'm just going to match this up a little, and this should be about right. So you can see what happens now if I hit play. Again, sorry about the simulation time, but with all this going on, it can take a second or so for each one. I would say when you start playing with a higher resolution, you can expect that to take quite a bit longer for your simulations when you play with the higher fluid resolutions. Okay, and if I just stop this and take a quick render, and I've rendered through the wrong camera. So I'm just going to render. I rendered through the perspective camera, which doesn't of course have the backing plate on it. Camera 1. Okay, and you can see here that we've got that background plate, and we've got it, you know, blowing this nice hole in the floor still, and we've got our shrapnel that's now, you know, looking a bit bigger and a bit nicer, a bit more variation in size. Problem is that you can't see the background plate through this. So one of the nice things when we did this, we did it with a layered shader. So if I go to material attributes, you can see here that we've got that layered shader that uses the ground blast as a transparency when this fluid container, 3D fluid texture container, is used as a transparency map to create the hole here with the displacement, and then create the hole also with the ground blast shader. So what I'm going to do is open the hypershade up, excuse me a second, and I'm going to take a look at our layered shader here. And what I want is a use background shader, which will allow Maya to see this background plate through this background. And I'm just going to put it in. I'm not going to cover its settings. If you're interested in the use background shader, we actually have a full tutorial on it. It's free of charge on the site in the Free Friday section of the forum. So I'm just going to go ahead and find the use background shader. There it is. So now I have this use background shader. I want to click on my layered shader. I can do it up here also. And what I want to do is get rid of the ground, because I don't need it anymore. I still need the ground blast, because we still want it to look like we've blown a hole in this whole background plate. So I'm just going to get rid of this ground, and I'm going to drag in instead a use background. So now when we take a render, let's just keep this one for comparison. You can see that we have this background plate, and we also have what looks now like a hole in our background plate, because as soon as this hole is blasted, our layered shader uses that transparency map from the fluid 3D texture and creates our darker hole in the floor here. In fact, if I up the resolution on this will make a deeper hole, so I can then and I'll also just rotate the camera up a little bit so you can see the hole better. Now you can see here our ground plane now actually breaks the horizon. I'll leave you to tweak this. I just want to show you that we are still generating that nice hole in the floor. I'll let the second one go off as well so the hole gets a bit deeper. And you can see here on the geometry where the hole is. Okay, I'll let this fireball clear upwards a little bit. Take another quick render. And you can already see here that our second material in our layered shader has come through because the geometry has been displaced and we're using displacement. Looks like we've got a hole in the ground, but because of that second material in our layered shader, it actually looks now like we've managed to blow a hole in this background plate, which of course we have not because it's just a still image. Now on my final video you saw we had different colored rocks. I literally just went in and changed the material properties of these to a more desert-like color. So I picked my color picker here and grabbed a few different lighter shades, and I did this for all 5 rocks until I had a variety of different colors I was happy with. As I'm not sure what background plate you'll be using, I'll leave that to you. I also put in another point light, and I turned on ray trace shadows for this light. So I'll just hit ray trace shadows. I think I used a 25 shadow rays. I can't actually remember what I tweaked for the final render, and a light angle of 0.5. So I'll just go in and drop in another point light as well. Okay, just raise this off the floor slightly. And if I take another render now, you'll see here that where I coloured my rocks, one issue that has cropped up, and this will be in the use background shader tutorial, but we'll just fix it here. You can actually see the reflection of the TIE fighter on the ground plane here, which is not at all what you'd expect from a sandy desert. This is simply because by default the use background shader is reflective, so we can go into our hypershade, click that use background shader, reflectivity, reflection limit, don't want any of that. And our point light here is probably way too bright for what we want. So I'm going to put that down to say 0.5, and I might turn it a little yellow, sort of almost sunset colour to match our background plate. But again, this is completely dependent on what you would have in your scene. And I might up the intensity on this a little bit. And we'll just hit render. I'll just show you that reflection has actually disappeared off our floor plane. As you can see now, we've got a softish shadow on the floor there. Our rocks appear to be slightly hovering off the ground. Again, that's quite an easy one to fix. I'll just stop this render and we'll take a look under the nParticle shape node, nParticle 2, which is our shrapnel, and what we want is collisions. And under collide width scale, I'll just turn this down to 0.1, and we should now get, let me just get a better angle on this. So I'm just trying to match the ground here with the backing plate. Okay, I'll be about fine for demonstration purposes. And with this width scale turned down, I should now get my rocks appearing like they're more on the floor. Again, you might want to play with this. It might come down to a value of 0.59. You might have to set it to 0.2. I'm going to get it close enough for demonstration purposes and then leave you to play with it. And I only have one colour on my rocks here. You might want to go ahead and assign a different shader to each rock, so you can get this nice variation in desert colour. I'll just do a quick render here. And you can see I've got my shadow on the ground, I've got my hole in the floor, I've got my rocks on the floor. And I already know, because I've done the final animation with pretty much this exact same setup, that I'm going to be happy with this. You might want to use a different background plate. Please, by all means, do. I'd love to see what you can come up with this tutorial. I'm going to call it quits now, but I hope you've learned something. And I think we get a nice end result on this one for the amount of time we've put in, which so far has been about 3 hours. And I'd love to see your work on the forum. So I hope to catch you with the next tutorial, which I believe I mentioned will be liquids in Maya. And I'll see you then. Thanks very much for watching. Goodbye.